Tards, beware. You are listening to Brothers of the Serpent podcast.
And welcome back, ladies and gentlemen, boys and girls, angels and demons and monsters and serpents, to Brothers of the Serpent podcast, episode 60. Coming to you not live from the 10x10x10 tangent cube of science, nestled amongst the dusty bones of an ancient seabed high atop the Everest Plateau. We are your hosts. I am Russ. This is my brother Kyle. What's up? We are the Serpentine Brotherhood.
Very sneaky.
And we are joined, as always, by our good friend and longhead from his secret bunker in his secret space station in outer space, Mr. Brett England, the Watcher. How you doing out there, buddy?
It's going well, man. I'm here, ready to surf the internet, find truth.
So let me ask you, are you anywhere near the coldest spot in the universe? Out there in outer space?
It's
really difficult to say.
it's a secret where he's at.
Oh, okay. All right, fine.
So what is
I can
this?
tell you.
Okay, yeah, don't do it, because
All
even
right.
telling them that you would have to kill him, you'd have to kill him.
And we're just building this listener base. I'm pretty sure that we're not going to gain listeners to the podcast if listening gets you killed.
That's right.
There was a glitch in the Matrix there when you were talking.
That's right. So what is this coldest space?
Space news!
Space news.
NASA has created the coldest ever spot in space to prove a theory predicted by the Watcher. To prove a theory predicted by Einstein 71 years ago about the way atoms behave at low temperatures.
Wait, 71?
72 years ago. Most likely. Most likely, sir. NASA has created the coldest spot in the known universe, and it is 10 billion times cooler than the depths of space.
Wow.
A team aboard the internet, which is probably like 1 degree different.
Yeah, that's really cool.
Once it's that far down, it's way down there. NASA's, let's see, a team aboard the International Space Station used a small box loaded with lasers and a vacuum chamber to hyperfreeze atoms in an attempt to better understand how gravity interacts with matter on the tiniest of scales. They created ultra-cold clouds of atoms known as Bose-Einstein condensates, BECs, in orbit for the first time. The research aims to prove a unified theory of fundamental forces of the universe, predicted but never proved by Einstein 71 years ago. It could pave the way for improved sensors, quantum computers, and atomic clocks for space navigation.
Yeah. Yeah, Einstein talked a lot about a unified field theory, but he was never able to quantify it, mainly because he was assassinated, because he was reading Charles Hapgood stuff.
I was just listening
totally
to
happened.
I was just listening to a podcast where the guy was telling a story about he was a student. He used to work with this professor who was the guy who invented lasers.
Man.
And he was like, the guy had just invented the laser and was like messing around with it in the lab. And he was like, you know, that the student was telling his professor, he's like, when are we going to do something that's actually going to have like a real world application? And the professor's like, what? Are you kidding me? This thing's going to revolutionize the world. Little did he know, it didn't really revolutionize the world, but they are making extremely cold spots in outer space.
That's right.
With lasers.
You can't really do anything cool in outer space without lasers. That was proven multiple times by Star Wars.
I tell you what, that guy made it way easier to build pyramids.
Yeah. Yeah, we use lasers every time we build something. Like, if we didn't have a laser, it'd be really hard to set your transit.
Yep. But, anyway, I thought that was pretty interesting.
That is cool. Oh, yeah. Blu-ray, DVDs, CDs? Anybody? Lasers.
That's so old school. Come on, solid state, crystals. I want to listen to music by vibrating crystals together.
Yeah, but they build those crystals using lasers.
Yeah, probably.
Yeah. Yeah. So I have this other space news thing about I'm sure some people have read this, like the Magna Planet.
That's space news.
The Space Force Space News. It is about the Magna Planet. That's what I call it. They're not calling that. It's called massively magnetic rogue planet hurtling through space close to Earth. So-called rogue planets have become a hot topic in astronomy. These planetary mass objects do not orbit stars as most planets do, but instead orbit galactic centers due to being ejected from the systems from which they formed. In fact, some of these wandering or starless planets have never been bound to a particular star at all, making them true rogues in a planetary sense. Rogue planets have been proposed as explanations for the ongoing Planet 9 mystery, which was the Planet 10 mystery before they kicked Pluto out as a planet, or Planet X, or why Uranus has such a peculiar alignment, meaning that it's laid down on its side, I think. Some astronomers believe the universe may be brimming with rogue planets, and a recent discovery made using the National Science Foundation's Very Large Array may be one of the first steps to confirming that theory. Scientists using the VLA just announced the first ever radio telescope detection of a rogue planet traveling through space untethered beyond our solar system. The object, given the excellent name SIMP-J01365663 plus 09334473, has a mass 12.7 times larger than Jupiter's, yet a magnetic field 200 times more powerful than the gas giants, making it a true anomaly. So it's only 12.7 times larger than Jupiter, but it has a magnetic field 200 times more powerful than Jupiter's. So. Magna Planet. The identity or classification of the rogue planet remains somewhat of a mystery because it seems to occupy a liminal space between brown dwarf and massive planet. Too big to be a planet, yet too cold to be a star. So a brown dwarf is a theoretical object, a failed star. Like, it's too big to be a planet, but not hot enough to start fusion, but it's warm, right? So it would have a surface temperature of around 80 or 90 degrees Celsius, but it's not fusing. So, you know. Yeah. Okay, that's a brown dwarf. Okay, so they're saying that this thing is between giant planet and brown dwarf. It's in between them. The most curious feature of the rogue body is its incredibly powerful magnetic field. Melody Cow, a Hubble postdoctoral fellow at Arizona State University who discovered SIMP J01365663 says the rogue planet, or whatever it is, could offer unique insights into the magnetic fields of planetary bodies. This planetary object is exciting because studying its magnetic dynamo mechanisms can give us new insights on how the same type of mechanisms can operate in extrasolar planets beyond our solar system. We think these mechanisms can work not only in brown dwarfs, but also in both gas giant and terrestrial planets. SIMP blah 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 lies just 20 light years away from Earth and was discovered through its radio emissions rather than through the traditional means of spotting planets through their gravitational effects. Yet another sign that the future of space exploration may lie in detecting radio signals. Which one will be the one to change human history? None of them will change human history. Stop saying that.
I have an idea. The Magna Planet should fly through Ringworld. And then
yank it along with it.
Create a whole bunch of energy. Yeah. Can power Ringworld with one pass-through.
So what's interesting is this is, as far as I know, this is the first extrasolar planet detected by anything other than gravitational measurements of other stars. Right. And rogue planets have been a theory for a long time, but have never really been detected until this one. And then the first one they find is weird, proving that the universe is weird. Yeah. If the first thing you find is weird, everything is weird.
If you didn't already know that, the universe is weird.
Yeah.
And also strange.
That's right. And I got that from mysteriousuniverse.org. Mysterious Universe. So, like, I think that's cool. It's also funny how, and again, this is Mysterious Universe, so they're not inclined to skirp derp, like alternative theories and other stuff like that. But it's interesting how much ignoring these scientists have to do of ancient myths and other things. You know, they're like, oh yeah, like they have this theory about rogue planets and they're probably really big and they're probably strange and they probably fly around and there's probably tons of them all over the universe. But that whole Sitchin thing about the planet flying through and like destroying, you know, this other planet is totally crap, right? It's completely crap.
The Watcher is pointing out that listeners should not be alarmed that the planet is warm because it's not due to CO2 levels in its atmosphere. It has to do with the gravitational force on its dense atmosphere, according to Feynman.
That's right. That's right. That's right.
Fear not.
Brown dwarves are not hot because of CO2. So, we were the sun weather guy was saying that wasn't he saying that we got a big ice age coming? I can't remember that video. Like, what was it?
Well, he was saying he was talking about how, like, looking at the Little Ice Age, there was a series of volcanic eruptions or whatever, and certain things that they think might have been due to the solar activity at the time that correlate with what's happening and what's been developing right now.
Yeah.
Or in the recent past. And so he was like, watch out, everybody. But I think he was basically saying that I don't know what they were calling it, the proxies for the Little Ice Age.
Oh, yeah.
You could call them, match what's going on now, but the ones that are happening now are of greater magnitude. Right? So that it could be, if it continues to line up with these things, it could result in, or like have the same result.
Like a medium ice age?
Possibly, yeah. Yeah.
A big little ice age. I mean, really, we're overdue for the next glacial period, right?
Yeah.
That's not what he's talking about, though. He's talking about other proxies like that may move us into some intermediary thing, like.
Yeah, I'm pretty sure, if I remember correctly, that he was comparing it all to the prerequisites to the Little Ice Age.
Right, which was like an anomalous period, basically.
Right.
Yeah. Okay.
And I don't remember what the period was, but it was, I guess, in the.
I mean, it ended in 1700, like with the beginning of the
Renaissance.
Yeah.
Or whatever,
yeah.
Yep. Little Ice Age happened due to lack of CO2 in the atmosphere.
Yeah. Well, it put an end to all the cathedral building.
Yeah.
Because before that, they had warm climates, and then like there was the ice age started. And then they had massive crop failure in Europe. Anyway, I don't know what happened.
That seems to be the thing. Like when it's warm enough for crops to be abundant, then people can do other things than get food.
Right.
So you can end up, building amazing
surplus.
stuff like the cathedral building and all that stuff that was going on. And then, if it gets really cold again, we're all going to go back to really spending most of our time trying to get food.
Right. Because food will be scarce. So like warm periods bring surplus, which allows you to do things like develop abilities to build things with stone and carve stuff. And here we go. Early 14th century through the mid 19th century is the Little Ice Age. A climate interval is what they're calling it.
Which is, I guess you could consider that some evidence that, the Great Pyramid and all of that massive building and stuff that was going on in many places in the world was probably shortly after the end of the last ice age when things warmed up and calmed down.
Right. It was post cataclysm but then they were like, but everybody who was left was freaking out about it, so they were building these massive structures. But I've been thinking this like recently about those things as being markers. I can't remember what got me started on this, but I was looking at them and I was like, these things are like enormous megalithic markers. They remind me of the whole thing where like part of the myths or whatever, where some deity is telling the person like, bury this knowledge and put a marker over it. And then after everything is over, the flood or the freezing or whatever, they come out of the Varas, come out of the Ark, they're told to go back to that place and dig up the knowledge.
Yeah.
And I also was remembering the thing about the pyramids having a watermark, a water line about 2/3 of the way up before the exterior stones were taken off of them. So.
Yeah, maybe they were earlier. I don't know.
Well, because that place, at least for those three, the ones on the Giza Plateau, during the Younger Dryas period, that place was like uniquely suited for life. It was actually like verdant. It wasn't a desert.
Fertile Crescent.
Yeah. Yeah, it wasn't a desert there. So it actually escaped a lot of the destruction.
Where does a crescent come from? I just now realized I don't really know why they call it a crescent. Is it actually crescent shaped, the area where they're talking about?
Yeah.
Due to a mountain range or like?
Yeah, I don't know. I can't remember what the shape of it is caused by. I don't know. Maybe one of the seas and a river. I have no idea. But I know the Mediterranean means between two rivers, right?
Ah.
Yeah.
Oh, Mediterranean between two terrains?
Yeah, it's like it means. Okay, here we go. The Watcher's pulling it up.
Oh. Is it that?
Maybe it is. Scroll up and see what he said. What did he say there?
Nothing yet.
Okay.
So we're looking at a map, picture of northeastern Africa, the continent of Africa, where it meets. There's the Dead Sea there,
Yeah.
or is that the Red Sea?
I don't know.
Red Sea and then Saudi Arabia.
Yeah.
That whole Arabian Peninsula.
I think the green area above it is the crescent.
Oh,
See it?
okay. So it crosses from Egypt along the isthmus between where the Mediterranean is to the north and the Red Sea, I believe, is to the south.
Yeah.
And it goes up over underneath Turkey and down to
Whatever that is.
whatever that is.
The Strait of Hormuz or something.
I don't know. I
Straits
can't.
of Hormuz.
I can't read the text.
The Persian Gulf.
Persian Gulf. Sorry. Don't know what I'm talking about.
The Straits of Hormuz might be that little short pass right there.
But I did remember the strange
point.
word isthmus,
Yeah, isthmus.
which is a small, narrow strip of land connecting two larger areas of land.
Yeah. But yeah, Mediterranean, as far as I know, means between two rivers, and it's talking about the Tigris and the Euphrates.
That's weird because the root word is terrain.
Yeah. Medi, between, or medium.
Yeah.
Yeah. Don't know.
Why did they put rivers on it? I don't know. Moving on.
Okay, so I have this other thing about the pyramids since we're talking about this. This is interesting. Physicists claim that the Great Pyramid of Giza focuses electromagnetic energy. So, I found this fascinating. The Great Pyramid of Giza remains one of the world's most enduring sources of mystery. For thousands of years, the Great Pyramid has stood in the desert of what is now El Giza, Egypt. El Giza, Egypt, to serve as a monument to the ingenuity and technical prowess of its builders. That's not what it serves as a monument to, but whatever. After its construction, the Great Pyramid bore the distinction of the world's tallest man-made structure for close to 4,000 years, or longer. Not bad for an oversized mortuary, which it isn't. One of the reasons the pyramids remains mysterious is the fact that there is still significant disagreement over how the pyramids could have been constructed with the materials and methods available at the time. Aside from the mystery over how the pyramids at Giza were built, there is the long-standing suspicion that the pyramids might have some unknown purpose or function which has been lost to history. Hidden structures and voids continue to be discovered within the pyramids, leading some to speculate that perhaps the pyramids still might contain more than meets the eye, despite the countless research projects and excavations conducted on them over the years. To build on that speculation, a new study conducted by an international team of physicists has concluded that the chambers inside the Great Pyramid might actually be capable of capturing and focusing electromagnetic energy.
Oh, yeah.
According to the authors, their research has, quote, revealed that the pyramid's chambers can collect and concentrate electromagnetic energy for both the surrounding conditions, unquote, and, quote, show that basically the pyramid scatters the electromagnetic waves and focuses them, unquote. The study has been published in the Journal of Applied Physics. While this study sounds like it might hint at further high strangeness surrounding the ancient Egyptians, researchers found that only electromagnetic radiation within a specific narrow wavelength has the ability to resonate within the pyramid. Furthermore, this discovery is purely theoretical, having been discovered through the use of advanced simulations.
But that kind of suggests
But they were precise.
precision.
Yeah. A scientific supervisor and coordinator of the research, Dr. Andrei Evilkin, I don't know how to say that, it points out in a press release, due to the lack of information about the physical properties of the pyramid, we had to use some massive stacks of assumptions. Still, he notes that with these assumptions made, we obtained interesting results that can find important practical applications. It remains unknown if the ancient Egyptians who built the Great Pyramid, which they didn't, were aware of this unique feature, or even if they knew what electromagnetic radiation was at all. And they probably didn't, because they didn't build it. While theories alleging the ancient Egyptians possessed technology or scientific knowledge far more advanced than what we know are often thrown around, we've yet to discover any concrete evidence supporting such claims, except for the giant pyramids that are standing right there in front of your face. Could it be possible that ancient cultures possess technology as advanced or even more advanced than our own? Who knows what we might find in the ground if we dig deep enough? Well, if you do it here, you'll find something below Clovis. No, anyway. God, that article was full of stacks of assumptions. Sorry for the commentary there. I just can't handle it.
That's cool, dude.
Yeah, so basically the gist of it is that physicists, taking what data they had on the materials and construction of the pyramid, ran some models and said that the chambers may be able to focus very specific frequencies of electromagnetic radiation
By scattering all the other ones.
That's right.
That's badass. Yeah. What did they need that one for? Oh, give me the frequency.
I know. Tell us the frequency. Dang it. Yeah. But it's probably not accurate because they had to make stacks of assumptions to do it. To build their models, they had to fill in variables.
But I mean, to say electromagnetic energy is you're saying a lot.
Right.
Because that encompasses
anything from deep infrared all the way up to gamma.
Yeah.
Yeah.
So we know it doesn't focus anything within the visual spectrum because it's dark as shit in there.
Or maybe it's not if you sit in there long enough.
Or maybe
in the dark.
If you have a specific set of eyes with nickel plates on them, you can go to an alien planet that has multiple suns and escape giant bats.
Tastes like burning nickels. Why did you burn the nickels? What are you talking about? I don't understand.
Stupid movie reference. Chronicles of Riddick.
Oh yeah.
But I was just thinking,
if
you don't have human eyes, if you had, we talked about this before, a different eyeball can perceive different areas of the spectrum in the electromagnetic spectrum. So,
yes.
We don't know who built it, but what if their eyes saw different things?
Yeah.
Saw a different spectrum.
We know that. I mean, the longhead skulls that have been found have very large ocular orbits. The eye holes for their skulls are very massive, so their eyes were probably.
Yeah, I know what ocular orbits are, man. Just kidding, I didn't know that. That's a cool name for an eye socket.
I thought you knew what they were.
What large ocular orbits you have, my dear. It's great.
Yeah, so they could have had totally different eyes than us, and they could have. I mean, I don't know if we know what the tissue was. The only longhead skulls that I've seen that have tissue on them have hair, some hair remnant on the skull.
Yeah.
But there's no indication of what their skin color was, or if that matters, or what their eyes looked like, except that based on the bones, they probably had much larger eyes than us. Which is interesting. Some people have speculated that they were nocturnal.
Maybe that's what the Eye of Ra is about. Is that's the thing that collects the energy.
Yeah. Yeah.
Of the pyramid. That specific frequency was special for some reason. And it's probably depicted all over the place what it was being used for. Or why.
Yeah. And then there's the sun disk, right?
Yeah.
Held in the horns, and the people are venerating it. And he's I don't think that's what's happening. But okay, whatever. Everything's a tomb and everything's being worshipped.
No, it's just warm.
Yeah. Well, the Watcher's pointing out that would explain the giant eyes on the Buddha statues in Southeast Asia. Right. There's a lot of ancient statuary that have enormous eyes.
Yeah, and there's the whole third eye thing too, right?
Yeah.
And Cyclops.
Yeah. Cyclops.
He is the third eye.
All he has is a third eye.
That's right.
How can it be his third eye if it's the only one he's got?
You just can't see the other two because they're under that massive brow.
Right. He closes them because he's just looking through his third eye. So, let's see. I've got these. Apparently, these booms, these mystery booms, have been happening again.
Oh yeah.
Yeah. So I was just looking up stuff, and there's several articles on these. Let's see. So.
Prepare for mystery.
So the first one I've got here, was from August 3rd. Mysterious unexplained booms heard near Oak Ridge National Laboratory, which is like, people are like, so there's a giant lab there. They're probably blowing things up. And it's not a big mystery. But
Because that's what they do in labs.
right. Everybody knows that in laboratories you blow shit up. Mysterious and unexplained booms continue to be heard in the skies over America. Last week, residents of historic Charleston, South Carolina, took to social media to express their confusion and fear over what some described as an earthquake or explosion heard and felt on Monday, July 23rd. Charleston native Jerry Sanders told ABC News 4 that the sound was powerful enough to rattle her home. She said the windows shook and in our house, and I was just surprised because I haven't really heard anything like that before around this area. I heard a huge boom and the windows rattled, and I thought maybe that they were doing some building. I thought maybe they were doing some kind of small explosion. That's what I thought.
Perhaps some destroying.
Right, perhaps they were doing some destroying. But that's what I thought because a lot of building is still going on in this neighborhood, so I just assumed probably that's what it was. The boom, whatever it was, could be heard throughout the greater Charleston area. Meteorologists assured social media users that there were no earthquakes or thunderstorms in the area, and the sound was likely caused by military training exercises taking place off the coast, which is one of their favorites.
Always the military's fault.
Yeah. Could sonic booms be to blame? Could the recent spate of booms nationwide imply increased military exercises or testing? Whatever the case, in Charleston, another unexplained anomalous sound just a few hours northwest may have a stranger cause, judging from its location. Police in Maryville, Tennessee received several calls on Monday, July 30th, around 9:30 p.m. from residents who heard what sounded like 4 loud booms or explosions. Maryville Police Chief Tony Crisp sent officers to investigate, but no explanation was found. We checked and did not find anything and could never establish the cause of that, Crisp told the county newspaper, The Blount Times. It's just a mystery at this point. While underground cave collapses or deep seismic activity is often cited as a possible cause of the booms in the area, University of Tennessee geologist Dr. Bob Hatcher told a local NBC affiliate that these explanations are unlikely. People have called me about them, and I have no concept of how to explain them. A boom like that, it's not likely an earthquake. We've talked about whether or not this could be a collapse in a cave. We have lots of caves around here, but that wouldn't necessarily produce a loud boom on the surface. Just debunked about 1,000 explanations in this.
Well, yeah, but also if they have any seismographs set up, it seems like a massive cave collapse would.
Yeah, would definitely run them off, yeah. Aside from cave systems, Maryville, Tennessee is also not far from the Department of Energy-funded Oak Ridge National Laboratory. Oak Ridge was responsible for enriching the uranium involved with the Manhattan Project, so they blow stuff up all the time.
Did you add that?
Yeah. And since its founding in 1942, it's been the home of some of the most advanced and classified energy and materials research the Department of Energy conducts. Not to mention numerous UFO sightings and reports.
No, back when they were enriching uranium, the key was do not blow anything up. Like Feynman went over there and I think it was that one, whatever
Yeah.
They
He was like, separate these, good
like,
grief.
He's like a young, just graduated from college.
Yeah.
And they send him over there, and he's like looking at the plans. They're showing him the blueprints for the building and everything. And they're like, and he's like, I realized I get like 15 minutes into the guy's presentation, and I don't know what these things are that he's talking about. And he's like racking his brain trying to figure out what are those things that he's talking about on the blueprints. Yeah. And he just like, points to one, and he's like, I just randomly guessed. He's like, so what happens if you close this valve? And the guy like looks at it, and then he looks up at him like all startled, and he grabs all the plans. He's like, oh my God, you're a genius. And he runs off. And it ended up being like some massive problem.
Yeah.
And he just like randomly.
Yeah, he's like, so what happens if you shut this valve?
He didn't know it was a valve. He was guessing to see if the guy was like, oh, that's not a valve. That's blah, blah, blah. But anyway, like when they finally built it, he went down there to check on it, like the follow-up, and realized that these guys are like running around on carts with like the canisters of enriched uranium, and they're just storing them all in this big massive storage unit, and they're like parking them all nicely arranged right next to each other.
Yeah, they're
and
stacking them right next to me. He's like, "What are you doing?" Yeah, and then but it was because of the secrecy. They weren't telling these guys what these things were.
The people didn't know, so he ended up having to
get permission to explain to them.
Yeah, the military call this whole meeting
to
say, look, I've got to explain to these people what they're doing because they don't know.
They are
and
handling the
blow
materials.
themselves up. So the key is do not blow things up in the lab.
Right. I'm just saying, when you mention Manhattan Project, you know that explosions are involved.
Right.
So this massive laboratory involved in Manhattan Project, case closed. Giant explosions.
Yeah. Yep, that's definitely what the sky booms are from.
Okay. So,
Like, hey guys, I just built a uranium bottle rocket. You wanna go test it out?
okay. So that's the first one, and the second one is Mystery of Unexplained Booms in Tennessee. So this is a continuation of the idea. So it's called Mystery of Unexplained Booms in Tennessee Deepens. Right. Earlier this month, eerie, familiar, unexplained booms were heard in eastern Tennessee. While mystery booms have become a fairly common but no less anomalous phenomenon of the past few years, the location of the booms was curious given the proximity to Oak Ridge National Laboratory, a frequent home of nuclear energy research where everything blows up all the time. Well, while the nearby research facility was passed over as a possible origin for the booms, the conflicting official explanations which have surfaced only add further intrigue to this incident. The United States Geological Survey confirmed a small magnitude 2.1 earthquake in the area on Friday, July 3rd, 4 days after the initial booms were reported. One resident said, "This second boom felt like my house was picked up and dropped." In the 24 hours that followed the July 3rd event, the USGS continued to revise its report, changing the magnitude to 1.9, then 2.4, and then finally back to 2.1. Finally, the USGS claimed that the boom was due to a nearby quarry blast.
I was gonna say that, like when we were growing up in Georgia, we used to hear these booms all the time. Just like sometimes they would just go on all day.
Yeah.
And every time they were having, we're like, "What is that?" "Oh, it's just a quarry."
Right.
Like everybody knew because they worked at the quarry or something.
Right.
I never knew anybody that worked at the quarry.
Yeah, me either.
All the booms that we heard that shook the glass in the windows was all said to be the quarry.
Right. Right. And the quarry, or at least the one that was near us, was closed for a long time.
Yeah, they
Full
had
of water.
They had another one a couple miles away, but
Yeah.
From that one.
Yeah.
But I mean, it's who knows.
Yeah. So, however, Carl Van Hoosier, Community Relations Manager for Vulcan Materials,
Yeah. That's
which
a good one.
owns the nearby quarry, isn't having it. Van Hoosier issued a statement claiming the USGS's story doesn't add up. The USGS is absolutely incorrect. There was no quarry blast today, or any time this week. A 2.1 earthquake is pretty extreme. Our blasts are controlled and small. It's an earthquake, not a quarry blast.
That's cool. Good old Vulcan.
Keeping the mystery alive. That's right.
All right, fellas, blow that clip.
Live long and quarry. This isn't the first time mystery booms have perplexed Tennessee officials. Tennessee does sit on an active seismological zone, after all. If it was an earthquake, though, why all the finger pointing at quarries? And then they have a picture of a military jet making a sonic boom, and they're saying because maybe earthquakes and quarries had nothing to do with the booms at all. The city of Maryville, meanwhile, issued their own statement about the confusing and conflicting explanations offered in the wake of the mystery booms. We have not found any visible evidence of a surface blast, and we can confirm it was not a result of a quarry blast. Local seismographs indicate a possible earthquake. However, we do not know for sure the cause of the event. Officials from the U.S. Geological Survey will need to make that determination. We expect to receive communication from the emergency management staff when the cause of the event is determined. Emergency management staff? Why would they need to be involved? Residents in Maryville, meanwhile, are just as confused. Okay, big booms again in Maryville. Well, what's going on? So what exactly is happening in Maryville, Tennessee? So it is interesting, like, I think the internet is one of the main reasons why people have gotten their interest up in this, because when we were growing up, there was no internet to allow us to like talk to people around and say, "Did you guys hear that? Did you hear that giant boom?" And everybody being like, "Okay, what the hell was that?" And start actually kind of like questioning officials. All of us at once, going, "Okay, what the f was that giant boom?"
Yeah.
Like it was rattling the things in my house, scared my kids, and I told them it was the quarry. And then Vulcan was like, "That's crap. We're not blowing anything up today." And so I think this is interesting. Like, this is the power of the internet and the power of communication.
Yeah, that's really cool.
Yeah.
But we still never find out.
Right. But at least we know the question exists.
Right. Yeah, and there was no way back then, like when we were growing up, that you would hear about other people in other cities around the U.S. or the world having the same,
Right.
Occurrences.
Exactly. So what's interesting is like eventually someone, a geologist or a physicist will look at this and be like, "Holy crap! Look at this gigantic thing that's happening," and then sit down to figure it out, get funds, and actually work on it instead of
We
just
should
trying
write a book called Booming.
Maybe it's because of the booming economy.
I cannot do that.
It's the economy, dude. That's what it is.
All right. We're going to take a quick break, and we'll come back and talk about more booms and other mysteries. We've got a whole bunch of stuff to talk about this episode, so we'll see you guys in like a very short amount of time for you.
The booming economy doesn't explain the Trump that's in the sky. And from inside the tangent cube of science, across the ethereal planes of the internets, Brothers of the Serpent podcast. We're back for the second half of the first hour. And we got some corrections to make already that we can thank the Watcher for. But we were just too busy with booms and trumpets to get to it.
Yeah, and I was actually just working on this on the encyclopedia, but it's Mesopotamia that is between two rivers, not Mediterranean.
Yeah, that's right.
Yeah. Mesopotamia. Mediterranean is like, you're right, it's Terra and
terrain.
Like the middle land is what it is. Like, yeah.
So the ocean is between land. Okay, great.
Yeah. Yeah. Mediterranean is in between land.
Thank you, Latin.
Mesopotamia is between two rivers. Land between water.
Thank you, Sumer.
That's right. Sumer is why we have summer.
Yeah. So I want to change gears a little bit. I have this theory, and it's one that I'm just going to throw it out there. Brand new, has not been vetted. Me and Russ have not been kicking it around for 10 years. This is something that came about due to our conversations on this podcast, having to do with physics and redshift and all the problems with the standard model and cosmology, and a recent podcast that I was listening to that just sparked the idea, and I think it's badass.
Okay.
So you guys can skirp derp it. You can comment on about how ridiculous it is.
All right, let's hear
But
it.
we could actually go through it maybe, and you could point out some problems. Okay, so this is the basic gist of the idea. We, meaning us on Earth, the Earth itself, or our solar system, or maybe even our galaxy, at one time passed very near to a black hole.
Okay.
So this theory actually includes the standard model of cosmology. Okay, as being correct. All of the problems with redshift and distance and everything.
Okay.
And the problem with quantum mechanics not really working with classical mechanics. Okay. Classical physics and quantum physics do not mesh, and they are looking right now. Physicists are trying to find a way to unify the two.
Yeah,
right? And
or
they're-
where the boundary is or whatever.
and they're struggling to unify them. So this also is an idea that may explain gravity or the problems that we have with figuring it out. So let's say, just to make it simple, that the solar system passed very near a black hole at one point in the past. So according to relativity, the time dilation for us would be so great that we have essentially evolved more in terms of the universe evolving than all of the rest of the universe.
Okay.
We have passed through so much more time, right? And it's not been apparent to us or whatever,
Yeah.
but
I got you.
in other words, the universe is static out there, and we have
Not do that.
basically preserved ourselves or something.
Okay.
You see what I'm saying?
Yeah.
So perhaps it's still happening. I don't know. But the idea is that, like, this is why we haven't found alien life,
Right.
because it can't catch up with us, or vice versa.
Okay.
Like, we have spent.
Okay. So
I
what
don't
you're
know if
saying?
I'm looking at it backwards. Maybe the whole idea is backwards, but
Because if what I know is right from the basic standard model, anything that passes near to a black hole is the thing that's frozen in time,
right.
not the external universe.
Okay, so we have basically been living for billions and billions and billions of years since this happened,
Yeah.
which separates us by that amount of time from everything else.
Yeah.
So when we look out into the universe, like, let's say it's still happening.
Yeah.
Let's say that there's a black hole that's very nearby, but we cannot tell.
Yeah.
But our time is being dilated
Yeah.
by the presence and by the nearness of it.
Yeah.
So that when we look out or say it happened in the past, like we went past it, like we were slingshotted, however you say that in the past tense,
Yeah.
around it.
Slungshot.
Slungshot. I almost did that, yeah.
Slangshotted.
So really what I was thinking is that it had happened at some point in the past.
Yeah.
So that basically we are now billions of years
Into the future.
into
from
the
where
future from where we were before.
We were. Right.
Whereas the rest of the universe is sort of the same. Like it's from our perspective,
Okay.
right? Just like if you went, I guess that would be the other way around. The rest of the universe would be billions of years in the future.
Right. Like the rest of the universe would seem to like move very quickly while we were near the black hole, and all this stuff would happen very fast. And then when we came away from the black hole, it would all slow down back to its normal deal, but it would have massively transformed across billions of years as we passed very near the black hole. That's my understanding. And
No, I think you're right. Okay,
Yeah.
okay. So, okay, Brett's saying it would explain why alien life is so interested in Earth.
it's like a living historical site because we're from the ancient universe, basically. So
Yeah,
ahead.
okay, so this is what I was thinking. Like, we have all these layers of geology and just all this crazy shit
Yeah.
that, like, seems so ridiculously ancient on the one hand, but then
Yeah.
it's like, wait a minute, what's going on here? Like, how did this happen so much?
Oh, I see what you're saying. Yeah. So like while we're in the black hole, all that shit's frozen. Okay. Okay. Keep going.
This is what I'm trying to work it out. Like, I didn't have to, I was building a structure at the time that I'm thinking about this, so I
Yeah.
didn't really get a chance to work on it. It was just the idea that like this is also the situation with all the red shifted everything out there,
Yeah.
because either we're still near it.
So everything's moving very fast.
Yeah.
Because we're actually slowed way down.
That's right.
Yeah. I got you.
And so they can't even catch up with us. In other words, like, an alien race wouldn't be able to.
Yeah.
Its radio signals wouldn't be able to get to us.
Right.
That's why we haven't picked up anything.
Or they
Like,
would be so deep shifted from it.
exactly.
The
That's
redshift of a radio signal, if we were deep in a black hole, would never reach us because they'd be so redshifted we wouldn't see
This
them.
could also explain the dark matter problem. Like, we're seeing a universe that's basically in stasis. We're not seeing. Is that right?
No, we're in stasis.
We're in stasis. Okay.
Yeah. The universe out
got
there
this
would
backwards in
Yeah,
my
the
head.
universe out there would be hauling ass relatively. Like we would see
This is why it's redshifted, because it's all hauling
it's
ass.
redshifted, and then there's unexplained accelerations and everything like
And this
that.
is why we can't figure out gravity, because our gravity is like in a total different,
Yeah.
like, micro ecosystem basically inside this,
Yeah.
right? So it doesn't make sense. So then when we go down to the quantum level, and we're looking at the fundamental building blocks of the universe and how they work, their physics is totally different.
Yeah.
Because they're not. They're actually like we're looking at it on a microcosmic scale, right?
Yeah. Yeah.
So when you try to extrapolate out from that into the system that we're in, if we're still close to the event horizon of this black hole, it wouldn't make any sense because
Right.
nothing out here is acting the same way.
Right. And anything out beyond the black hole is acting.
Doesn't seem to make any sense either.
Yeah.
So it's like we're like this isolated, intelligent race, basically intelligent life that is trying to figure out the universe in one of the most unique situations that you could be in the universe.
Yeah.
Which is why nothing makes any sense. When we look at a distance, we're seeing light that can't catch up with. It's
Yeah.
like basically.
We know that eventually it's not good. Like, so it eventually will pass out of our universe, which means that other stuff has already done that. Yeah.
Yeah.
Okay, so have you heard
Which
of...
maybe explaining dark matter is what I'm trying to say.
Yeah,
It's
I
like
got
the
you.
dark matter is like we're detecting sort of gravitate. We're seeing the fact that these large systems are held together by all this mass that we can't see because its light can't get us anymore.
Right, this low-level light, and it's so deeply shifted that
Yeah.
it's below what we can see as the electromagnetic spectrum. I got you. Okay, so have you heard of the theory of what are they
I
called?
was also thinking. Sorry,
Go ahead.
that there's this whole idea of binary star systems, and we're like, where's our freaking other?
Yeah, where's the dark star?
Yeah. maybe something happened to it.
Right. Or maybe it is the black hole.
That's what I'm talking about.
Yeah.
Yeah. Maybe it is the
It
black
imploded,
hole.
and yeah.
And this is probably some of why all our solar system is so out of whack everywhere.
Yeah. Right. Yeah, I've always thought of that as the primordial dragon. That the entire solar system looks like it was massively affected by something enormous, or at least enormously massed, right? Maybe
Yeah.
not big in terms of size, but had enormous mass that passed through the solar system or close to it and knocked over all the planets. And
Yeah.
I mean, even Jupiter has a 3-degree tilt relative to the sun, which is
Yeah.
enormous for Jupiter. It's like, what kind of energy would take to tilt Jupiter 3 degrees?
Yeah.
And, knock Neptune over or whatever, Uranus, and completely flip Venus over entirely, knock the Earth over. So, okay, so there's this theory. It would also be interesting about the cosmic microwave background, right? That's the stuff that's reaching the event horizon of the black hole and being pulled and accelerated. And it looks like a cosmic microwave background, and that's why it's divided perfectly along this axis that seems to align with Earth, because it's the axis of the black hole.
Holy shit.
So there's this theory.
Yeah.
There's this theory about micro black holes. Okay. Basically, the idea is that during the Big Bang, there were areas of compression that were so high that event horizons, or that singularities would be created without having the requisite mass for their own internal gravity to cause it to collapse. You see what I'm saying?
Okay.
So like
Sort
like the normal way of a black hole being created is like when a star with enough mass, there's a certain threshold of mass that a star has to have, but once it runs out of fusion material, its core,
Yeah, to push it apart.
its core, fusion keeping it apart.
Right.
There's this like weird balance of explosion and implosion happening that keeps
Yes.
a star stable for billions of years. Once it runs out of things to burn, its core just collapses
Yeah.
under its own gravity and becomes a singularity, and that blows off the external. Yeah, exactly. It's called
I love this button.
supernova. That's right. So that collapse never stops taking place, theoretically, because as it folds space-time in around itself, the collapse slows down relative to any outside observer.
Okay, yeah.
So any black hole is actually continuing to collapse. It can't ever stop, really, because the more compressed it gets, the higher its surface gravity will be, and the more it will crush itself. So, but because it
So the
folds,
more it's accelerating away from basically.
right. So the more it folds space around itself, but the slower it becomes, and so like relative to the outside universe, the collapse could last the entire length of the life of the universe itself. It'll never finish because it effectively slows down and stops relative to everything else, right? That's why time gets so dilated when you get close to it, because you're getting into that effect. But during the period of the Big Bang, in the fractions of microseconds right after it happened, when the compression of energy in this tiny area was so high that like tiny amounts of matter could actually collapse
Become black holes.
and become black holes themselves and become like get caught in this endless loop of collapsing. And then as they circled through this highly energetic universe, they would continue to pull in matter into themselves. So as the universe continues to expand, the theory is that some of them, not most of them, won't survive because there's the Hawking radiation, which is a way that
Right.
black holes get rid of energy. So most of them would just fizz out almost instantly. But some of them that had like larger amounts of matter, like let's say that it was the size of Earth, amount of mass the size of Earth collapsed, right? And then it was gaining enough mass by circling around to keep itself from collapsing, and it started to slowly build up. So now let's say it's the size of like an electron. It has the mass of Jupiter. I'm just guessing, right? It has the mass of Jupiter, but it's the size of an electron.
Yeah.
It would almost affect nothing. Its gravity well would be so tiny.
Right, due to the inverse square law, right?
Right. But if it passed through you, it'd kill you. It'd put a hole in
Yeah.
you that would be unexplained, right? But it would be a microscopic.
So I'm thinking of something like that, but slightly larger, like large enough to
Right,
perhaps
so-
pass and affect the solar system.
So this is what I'm suggesting. And this is not a theory, but it has been suggested by people. What if the sun caught one? And this thing is circling inside the sun. And it's been getting bigger and bigger, more massive for a long time. Enough to like, for its effect to affect the whole entire solar system, to give us this weird. You see what I'm saying? So
Yeah.
it comes sailing through the solar system and knocks planets over and everything like that, and then the sun catches it. Now this thing is orbiting in the core of the sun. It's like orbiting the center
Isn't
of.
there some data that suggests? Okay, so precession could actually be that the whole solar system is orbiting a common center,
Right.
and that would be that thing
Yes.
that we can't see.
Right.
And this is why, like, sometimes
could actually-
it throws balls of ice at us.
Right. But it could actually be caught in the sun, inside of it. You see what I'm saying? Like a black hole. Now it's
Legit.
Like let's say it's the size of a little ball bearing now.
That's what the sunspots and stuff are. Like.
Yeah. As it gets close to the surface, it causes sunspots. And the sun would actually be orbiting a common center of mass with this thing, because it would be more massive than the sun at this point, right?
I cannot do that.
So like they would be orbiting each other, but because it's inside the sun, maybe it wouldn't be more massive than the sun, but they could be orbiting, and that would cause precession.
Yeah. That's cool.
You know, people have thought. One theory was that the Tunguska explosion was actually a micro black hole coming, and that's why they never found a crater. It actually just passed all the way through the Earth and went out the other side. For a little while, there was a search for the exit. You know, people tried to determine the angle of approach and like where it would have gone through the planet, and it would just gone through the planet and chewed up a bunch of shit, like made a tiny microscopic tunnel all the way through the planet and then exited somewhere.
Yeah.
But they never found an exit.
Well,
so-
the exit could have been Tunguska.
That's right. It could have been Tunguska, but like
The exit wound is always larger than the entrance.
in this case, it should be the same. But yeah, because it's not the same as a projectile. It isn't actually running into anything. You know what I mean?
Okay. But after it passes through all that dense matter,
It'd be slightly larger.
then when
slightly
it
more
comes
massive.
out, it's like the energy front, almost like we were just looking at the sonic boom, right,
Yeah,
in front of the jet. And like
Yeah.
once it passes it,
yeah, yeah. But it wouldn't have to be moving that quickly. You know, it's more like think of like running a vacuum cleaner hose through dust. You know, it's just like. And you can make this
Yeah, I
this
see what
trail
you're
through the
saying.
dust. It doesn't necessarily like it's not actually running into shit and pushing stuff out of its way. It's a Hoover.
yeah,
So
that's interesting.
yeah. So that's an interesting idea. The idea that we're in some kind of gravitic effect that's making the universe look weird and making our quantum physics strange and making like this time dilation stuff happen.
So that's why, like on the local level, everything there's symmetry.
yeah.
You know, when we had classical physics, like these things just made sense. Now we didn't have, we're still developing theories to explain these forces that we don't understand.
Yeah.
I'm not claiming that this is explaining any of those inertia, gravity, and all that stuff. What I'm trying to say is the fact that we cannot unify
Yeah.
the quantum with the macro, I guess what you could call it, classical physics, we cannot figure out, and then gravity is this one specific force that we just cannot plug into anything. And then they're certain, and they're finding all these crazy things in quantum mechanics. They've got all these theories going. String theory was a big one that went for a while, and it's like, a lot of physicists are like, man, I wish, people would put some time into some other ones, and it just doesn't. There's too many problems. Like physics, the physics of string theory ends up being 10-dimensional. They're like, shit. We know that's not the case, and that's a massive problem. Yeah, they can't figure it out. So there's just all the. Anyway, it was the idea that, like, what if, the way they typically, like physicists typically look at it, they try to find the simplest situation, to study, and then extrapolate out. Right. So elimination of variables. Yeah. So in our local situation, there are some things that are normal, but then as soon as you try to look out into the cosmos, it doesn't make sense. Yeah. And then if you go down to the quantum level, which is the actual, what we consider now the building blocks, of the universe, they don't make sense. Right. Because they're in the local situation, they're not behaving the same way that macro objects are behaving inside this time-dilated, highly gravitic, whatever situation that we're in. Yeah. So it seems like perhaps there is an external reason why why we cannot unify. That was the idea. Yeah. And so, all of the, I don't know if anybody out there has seen that movie. Dang it! Now I can't think of it. Interstellar? Yeah, Interstellar. Right. Yeah. Like they're trying to describe, the strange effects of being in that. Yeah. In the singularity. Dilated. Like the time dilation. So I was thinking, what if that's happening on a massive scale? Yeah. And that's why nothing looks right. Like we can't unify anything. Well, we look out at galaxies and we see that they're all basically accretion disks around enormous black holes, or at least that's what the cosmological standard model says. Yeah. That galaxies are basically accretion disks around supermassive black holes. Yes. So technically our galaxy should be the same, which puts us in its sphere of influence. Right. So we should expect some kind of time dilation from it. Yeah, there would be. Yeah. Right. But I was thinking something a little bit more. I guess it could be our galaxy, because it's like what you were talking about before, the like type whatever stars or whatever. Type 1A star. Yeah. I can't ever remember. Main sequence stars. Yeah, main sequence stars. That they're looking at these stars in our galaxy and then looking out at other stars. Yeah. And saying, okay, these are all main sequence stars, but they're all redshifted. Yeah. So maybe it is something having to do with our galaxy as a whole. Yeah. But at the same time, they're looking at our galaxy and saying, like, where's all the mass? Or is the dark matter situation only? It's only in distant galaxies. The galaxy clusters really is what they look at. Okay. They see galaxy. Is anybody considering this then? That the effects? I don't know. See, I don't know, because the inverse square law would say that we're so far away from the center of that galaxy that, like, it shouldn't be. But they don't know what the size of they've got these theoretical ideas that it's 3 million solar masses or whatever the galaxy, the black hole at the center of the Milky Way, but they don't know because there's an enormous dust shield between us and it. We can't see the core. Yeah. Like one of the black spots in the Milky Way that you see is the dust, is the core, but it's covered in dust. Yeah. But I was also thinking, I guess, a little more on the local. One day that thing will light up, though. Yeah. I was thinking a little more local than that because I was also I was thinking in terms of alien life, like why are we not finding it, or why are we not finding other intelligent life? Why is it not coming here? Like, you have the Fermi paradox. The Fermi paradox. Yeah. And that could explain it. Yeah. Right? So that we're out of reach. Yeah. So we know we're traveling through what they call the local bubble. We've talked about this before. Yes. Caused by a supernova at some point in the past. Now, it could have been a supernova of our binary companion, and it's become a black hole, or maybe a very massive neutron star. But if it was a neutron star, we would see it.
because it would be still really bright. It'd be like a white dwarf, basically. But if it had enough mass to collapse into a singularity, then it would be almost completely invisible, and it would not have an accretion disk yet because
Doesn't have enough matter around it, or
it hasn't had enough time.
Collided with it.
It hasn't had enough time to collect it.
Yeah.
And the only thing that black holes put out, energy-wise, is gravity and magnetism. So
Yeah.
we wouldn't necessarily see it.
Yeah, that's kind of what I'm thinking. Like,
So if we're in orbit around a black hole that used to be our binary companion, now like people might say, well, like if it collapsed to a black hole, it should suck the sun in. That's not true. Like, it has the same mass, so its inverse square law of gravity wouldn't change really. It would just become more concentrated, so that you could actually get closer to its surface gravity. You see what I'm saying?
Yeah.
Like the star itself blows a bunch of its mass off, so that would change a little bit. But it collapses and retains the same mass. So now it's much more intense because it's so small, because it's so concentrated. But overall, it has the same gravity as it did before, because you're measuring it the same way, right? Distance from center of mass to blah, blah, blah. And its center of mass is the same. So
yeah.
so a star in a binary, one of them could collapse into a black hole and not affect the other one at all, technically.
So it would be like, if that were happening, that the universe that we're looking out to see is
And that would kind of make
basically so far in the future from when we actually entered into the gravitational field of this black
and it's
hole.
moving too fast too. It's
Right.
moving very quickly. Yeah, like there's a time dilation. In other words, we're slowed down relative to the rest of the universe.
Right. So our whole ideas about the age of the universe and when the Big Bang was and all this kind of stuff is just totally wrong, because
Yeah.
we're in this unique position
Yeah,
of being like sped up,
and we're trying to measure it.
and we're frozen in time, and the rest of the
Right.
universe is actually hauling ass, and we're trying to measure it and compare
Yeah.
it to what we've got here locally.
Yeah,
And so we're looking at our star and we're saying, oh, well, you know, the age is like this, and this is kind of the way it goes. And
Yeah.
we're looking out at the rest of them and saying, you know, they're going to be like this, but we could be just totally.
and like going back to the alien life idea, this may another reason why this may explain why we aren't being contacted by any of them is because they rise and fall all the time, and it happens almost instantaneously relative to us. Like they rise up in their civilization, they become massive and blah blah blah, and they collapse, or they all die out from some.
Yeah, exactly.
Right, it's too quick.
So we get like these fast radio bursts.
yeah, that was a civilization. Just
Oh my
rose and
God.
fall. Yeah.
Okay, the Watcher wants to jump in on and script rip me. Let's just talk about how like this whole theory is ridiculous.
Yeah, let's hear it.
So yeah, nail me, bro. Nail me to the wall.
No, I wasn't going to script her, but I actually like this concept a lot. But what it made me think of
He's being
was
nice.
so the revolution of mathematics caused by calculus was that it could deal with velocity at time equaling 0. So like if you're coming across like a parabolic curve, you can figure out speed at any given point along that curve. Or it's where the whole concept of you can either have position or you can have velocity. If we're influenced by this black hole, it would be the equivalent of us essentially being at time 0. So everything that happens here relative to everything else is completely unrelated,
Stand down.
Yeah,
which would explain all of the things you're talking about, like why redshift, why nothing makes any sense, why we have all these problems, is because we literally are in a frame of reference that is completely singular, and nothing is going to make sense if we look outside.
Yeah, no, it's not. I see your analogy. It isn't actually time equals 0, but you're saying that basically we're slowed down so much that it's functionally time equals 0. Is that what you're saying?
Right.
It's not really.
And that,
time
like,
still
the
passes.
implications of that potentially are things like, you know, they say that Anunnaki lived for like, you know, hundreds of thousands of years. Well, they could have just like
Left the local system.
Left the local effect.
system and then turned around and come back because they're like, oh crap, I forgot my wallet. But
I
it was
cannot
like,
do
you know, 30,000 years.
Stand down. Or die.
Yeah, dude.
Yeah. If the black hole effect itself is in the sun, like I was initially saying, if it's actually in the sun itself, if there's some kind of micro black hole caught in the core of the sun causing this local dilation effect, then the actual orbit of the planet that Sitchin talked about, that the Sumerians talked about would go outside of its
Yes.
Oh my god, then it would take ever
Yes.
long to come
and that
back.
would be
Once
why
again, it would
it's,
thousands and thousands and thousands of years to get back here.
right, and that's why it's the house of millions of years. Oh my god! Because as it like the farther out of the system it goes, the less dilation it's facing, which
Yes.
means that like in terms of what actually
They
that would
can-
make,
they can-
them die really fast. That would make them die really fast. They should die off really quickly because as they went out of the dilation, their time would speed up relative to us. So that
Yeah,
doesn't
that's
work.
true. See, I keep doing the same thing.
Yeah. You gotta make,
Right, but when they
But-
came into our sphere of like,
So-
this would be the alien time to them, so it would elongate their
But
lifespan
unless
they're here.
unless it's
Unless
a
it was
binary.
the idea unless it was the idea that they came closer to the sun than us.
No. If well,
We'll find out soon, folks, because Sun Probe.
well, okay. So like, ignore what I said because I'm getting it backwards. Let's put it back at the binary system. The collapsed star is the sun's binary. So as Nibiru goes out,
it
gets closer to the dark star, and it faces higher time dilation.
Yeah.
So that could work.
It's a cool idea.
Yeah,
It's
it's an interesting idea using time dilation.
we'll kick it around. I think like okay, so one of
cannot do
the
that.
problems that I have, like we've talked about electric universe, we talked about elastic universe, but I keep going back to these standard model
do that.
physicists that are they're doing their best to take the data and apply it using experiments and develop new theories. And they're struggling with so many theories that they come up with. They're like, well, we thought it might be this, we thought it might be this, and they develop an experiment and prove themselves wrong over and over and over and over and over, and they're doing this over and over and over. I can't, I'm never going to be able to know what they know or do the math that they do or know all of the data that they use in the experiments that they never published that proved all of their myriad theories wrong. But it's like certain ones, I trust their methods.
Yeah.
Right? And they are eliminating piece by piece. They're falsifying, right?
Yeah.
And now they have theories that interpret what the results of their experiments are. Those things I can disagree with, and that's fine. Nobody agrees
Yeah.
fully. I mean, even among all these physicists that I listen to, they disagree with each other all the time.
Yeah.
It's just that, like, the one thing I can't get past is that, like, they are dealing with the data, and I don't have the machines or the telescopes or all the stuff to gather that data that they have that they can then develop experiments
May the weaver's threads grace
do.
you
And
travel.
they're doing all this work, and there's all this money, and they're just trying to unify or try to find some connection between these extremely difficult problems, and difficult things to understand, like quantum physics. And they're just like, they're not doing it. It's not happening.
Yeah. There's also, with radio telescope, with the advent of the radio telescope, there's a huge confirmation bias issue because the amount of data that radio telescopes can collect is enormous and very complex, right? It isn't the same as visual spectrum stuff, right? When you get a regular telescope and you look out through it, your eye does all the data interpretation for you. It's visual.
Yeah.
Your brain handles the entire, like, you're looking at this very complicated series of electromagnetic waves coming in, but your eye does all the data processing in your brain and everything like that, and you're like, that's a star, and that's a galaxy,
Yeah.
that's a nebula, right? And now there's obviously more things they can do, spectrographs and things like that, but the point is that radio telescopes, we can't do that. There is no looking through it and letting your eye do most of the interpretation.
Yeah.
So there's this enormous amount of data, and it's computer data, right? And you can model it out, but it basically comes out in a series of waves. It's very complex, and they have vast amounts of data so basically like one of these, like the VLA, the Very Large Array, will just look at a place in the sky and kind of like follow this area over the course of a night, and they get this enormous amount of data, and they store it. And then what happens is when somebody comes up with an idea, they're like, okay, I want to kind of look at this, and they'll go and they'll kind of search through the data to see if there's something that they're looking for in there. Yeah. This is why they say, physicists have found, blah, blah, blah pulsars. It's because they've gone through all this radio telescope data doing a search for that particular kind of object, looking for a signature that they think is that particular kind of object. And when they find the signatures, they're like, okay, here's a pulsar, here's a pulsar, here's a pulsar. Yeah. The problem is that causes confirmation bias because you're not looking at all the data. You're just searching through it for pieces of it. Okay, so I'm not pointing out anything in particular that's bad because radio telescopes are awesome. I'm just saying that there's so much data that we can't process by ourselves like you can with your eye with an optical telescope. So this causes confirmation bias in the sense that they only find the things that they go to look for.
Yeah.
Right? Like there's tons of data in there that haven't been looked at because nobody's searched for whatever that particular thing is, and so nobody knows what it is. It hasn't been looked at, Wow. And there is no way, really, because the amounts of data are so massive. There is no way.
Yeah, we need to build a supercomputer to analyze the data.
Yeah, so SETI has done this.
We should build a quantum computer. But it would probably explode.
SETI has done this. This is what I'm saying. SETI is the only astronomical observation program that I know of that has done this.
Yes.
They have all this data, and they don't know what to look for.
Yeah.
So they have these humongous amounts of data, and they know that they don't have the computer processing power to search through it all. So they've made this thing. They've made this distributed computer network where they basically you can download a free little client, and they'll send you packets of data. And sometimes, when I do this on my computer, so whenever I'm not using it, whenever it's idle, it starts with this program up and downloads some data from SETI and processes it for them, and then sends them the results, right? And it goes through everything. You can watch it happen. It runs all this. You see all this static, basically radio static, and then it figure out what everything is, and then puts that into the conclusions, and then picks up another block of data and does the same thing. And they're just looking for anything. Yeah. But they're looking through all the data because they don't know what to look for. So
and that's a massive project, and there's there's a lot of script derps out there that are script charting it they've been around for so long, they never found anything. Well, they found one blip, and there's not a big deal. Blah blah blah. But the people who developed it were not expecting to just suddenly find something immediately. They're like, this is a multi-generational project. It's not, we have to do this.
Yeah.
So it is really cool.
I cannot do that.
But if we're in a black hole, we're never going to find anything because it's deeply redshifted. We're looking for radio signals, and radio signals are going to arrive here as not radio signals because they will have been shifted. Yeah. All right, so we're going to take another quick break and come back for the second half of the show. And keep looking for aliens. Yep. And snakes in space. So I had this thing that I've been thinking about. It's kind of been bothering me. Every week we come out here and we have these discussions, and I just keep getting this feeling that there are people listening to us. Hundreds of people listening to us right now.
I'm getting the chills, man.
They're listening right now. I don't know what to do about it. We know you're out there. Anyway, we're going to ignore you. So, what was your...
So we got this new soundboard. The Russ's suggestion. and it's great. Anyway, I'm trying to use it a lot, and it's probably going to be used a lot, and then we'll kind of like, mellow out on the soundboard a little bit.
Probably.
But deal with it. So, all right, I have just a little bit more I wanted to talk about with this idea. Talking about this idea of time dilation, if our whole system or local system has been affected by the high gravitational field of a black hole or something to that nature, and how it might change the effects from the quantum to the classical physics to the macro, or
Like from quantum to classical mechanics is what you're talking
yeah,
about.
and out in the the cosmological theories. Okay, so talked a lot about the cosmological theories, and I just wanted to go into a little bit of detail on the quantum problem. So there's this, the idea of light being a particle or a wave, and that it's basically both, or that there's this potential. And when we quote unquote look at it, or when we try to detect it, or when we try to measure it, most physicists talk about it in terms of measuring. When you try to measure a particle, or something like a wave, it collapses and becomes a particle. And that the act of measuring a particle on the quantum level is to interact with it. You have to interact with it. So you disturb its previous state, whatever its state is naturally. In order to measure it, you have to cause some interaction, and that interaction then changes its state. So it's impossible to know or measure what it was before you measured it. So I was thinking about that in these terms, and like,
And I just want to point out that philosophically speaking, that completely destroys the concept of the objective observer. But
absolutely.
But like modern day scientists still maintain this idea of objectivity. But philosophically, that you basically used physics.
This is why physicists hate philosophy.
That's right.
Because in classical physics and classical mechanics, you can be an objective observer.
Right, an observer that does not affect what he's observing.
Right, but because really, like when you're thinking about it, in classical mechanics, you're dealing with a system where photons or waves of light or whatever they are already bombarding the thing that you're measuring, and you're using the reflections of that light to measure it. Its speed, its position, whatever.
Yeah.
On the quantum level, you're actually trying to measure the thing that is bouncing off of, or has the potential to bounce off of, other quantum particles that are also bouncing off of other quantum particles, so on and so forth. So one of the things I don't know about the experiments in quantum physics and quantum mechanics is how they can say that they have successfully isolated a quantum particle from any other interactions with anything else. And I think that they basically consider it a probability, that there is a high enough probability that the quantum particle that they are attempting to measure has not already interacted with others. And they build massive machines and Faraday cages and get things
Vacuum
really
chambers.
cold and
Yeah.
pull vacuums and do all kinds of stuff.
And they isolate it with lasers.
Yeah, which is basically the original story we were talking about, space lasers and
Yeah.
making things really cold.
Yeah.
But my thought is that these waves of light or particles of light or whatever they are in their state, when they're entering the local system that is under the effects of this very unique situation with this theory, right? We're say near the edges of a black hole. That they are already doing this. Like when they get here through this dilation or whatever it is, or this concentration of matter or whatever it is going on in this area, that their states change, like on the quantum level.
Yeah.
So and for us to isolate a quantum particle is to do everything that we can to
cannot do
negate
that.
the properties that we are used to in our local bubble, which would have these properties of this black hole situation.
Yeah.
So if they could actually successfully do it to a high probability, then
Stand
that
down or
quantum
die.
particle that they're looking at is not the same as a multitude of quantum particles that are naturally in the local bubble
Yeah.
that would make up the classical mechanics, okay? So that as soon as they try to measure it with an instrument that is designed using all of the properties of matter and physics in the classical mechanics and classical physics of our local system, they end up changing its state
Yeah.
to match the system that we're in. So it either, you see what I'm saying? So like you collapse the wave function, or the particle becomes a wave, because it is, when you isolate it, say it has the potential to be either.
Yeah.
But the moment you interact with it in one way or another with
You're
something
knocking
else,
it out of the isolation. You're saying.
exactly,
Yeah.
which is why its state changes. So perhaps in another area of the universe, this doesn't happen, or it happens more regularly in one direction or the other.
Yeah.
Whereas where we are, it's random. You can't figure it out. Like,
Right.
why does it?
Another thing I was thinking of that's interesting in terms of your idea
Cannot do that.
is what's called the
Stand down.
Voyager velocity problem, or the Voyager acceleration issue, which is that the Voyager probes, which have been leaving the solar system for, the past decade or so, they're trying to figure, I think they've decided now that they've left the heliosheath, which is the
Stand down.
the big
Die.
bubble around the sun, that the place where the solar flux of the sun is equal to the incoming interstellar flux from all the other stars, and so it kind of makes this transition.
Discontinuity. Of,
Yeah,
Yeah.
It makes this transition point, and make the heliosheath a bubble around the solar system. They've decided that the Voyager probes have passed through that, but for the past 10 years or so, they've been trying to figure out if there's this anomalous acceleration that these probes have. They're going a little bit faster than they should be. Right, but the velocity is not quite.
They're starting to redshift.
That's right.
Holy
They're
shit.
redshifting as they leave the influence of the star, and maybe are passing deeper into the influence of this, or they're passing out of the influence of whatever local gravity bubble we have.
Cannot do that.
You see what I'm saying?
Yeah.
So I just thought that was interesting. Like, who knows? This would also depend on, like, if the sun and this other thing are orbiting each other. Like, go look at models of a binary star system and their orbits. They're complex. It's not a simple, because if they're roughly equal mass, then their orbits are complex and weird.
Yeah.
They kind of slingshot around each other, and they go way out, and then they come close.
Yeah.
And if they're like of different masses, then you have the even more complex thing going on.
And then the closer we get in that system, the more time is dilated, and
Right.
it just like, and then the further away it gets, the faster it goes. But that's not really what's happening. It's only according to us,
Yeah.
the observer, from our position. So it would really screw up all of our calculations about what's going on.
So let's say that it's a binary system. The dark star, the thing that's the black hole that's causing this dilation, is much more massive than the sun, but it's very small in terms of size.
Yeah.
Okay. I mean, it would be minuscule. So let's say that it has, 20 or 30 solar masses. Okay. So it used to be a very large star relative to the sun. The sun's a yellow dwarf, basically. It's a tiny star relative to most. It's not even a main sequence. Like, it's a small star. Okay. So let's say that this thing has 20 or 30 solar masses, which means that the sun is mostly orbiting it, right? It isn't moving a whole lot.
Yeah.
The sun is basically going around it, which is what causes the precessional
Precession.
cycle. But let's say that they would have some kind of mutual
Deviations
orbit.
and- yeah.
It would move a little bit. It would kind of go back and forth, right? So the sun would get closer to it and then pass away. And as the sun got closer to it, we passed deeper into the dilation. So the period while we're in its dilation, like relative, what it would seem to us that we're there longer, right? It's basically like, is that right? No, it would seem to us
It'd
that
be
we're
the other way around,
Right,
yeah.
we're long. We spend a lot more time away from it than we do near it. So now look at the Yuga cycle.
That's Yes.
The Golden Age is like much longer than the Kali, which is on the other side.
We're all on the same page here.
Yeah.
This is why the Sati Yuga
Yeah, the
is
Satya
longer than
Yuga.
the Kali Yuga.
Like the Kali Yuga is the smallest. The next one up is twice as long as the Kali.
Yeah.
The next one up from that is twice as long as that one, and then the Satya Yuga is twice as long. Yeah, so that's what I was going for. Is that like that could be indicative of our orbit with this thing? Is that we're in the Kali Yuga when we're closest to it, basically.
The other thing I thought of was the asymmetrical distribution of the precessional constellations.
Yeah.
So some of them take up more than 30%, or I mean, I'm sorry, 30 degrees of arc in the sky.
Yeah.
And it's because, but they are technically the same time. But it is the intricacies of our orbit
Yeah.
that change.
I see. That's interesting.
Dude.
Yeah. I don't
Fun
know.
stuff to think about.
I don't know if that would work because we also pass through those as we spin and as we orbit the sun.
That's true.
But I get what you're saying. Like the idea that there's like the actual precessional cycles, like it would appear that.
Well, yeah, I'm talking about the long cycle. Like they calculated the 25,000 years.
Yeah.
Whatever.
But the
like,
but the relative size that we see in the sky is not going to have anything to do with that. We would just. The pointer would basically stay in some constellations much longer through the precessional cycle, but we pass through all 12 of them every day.
Right.
Yeah.
Yeah.
Because we're not moving through the dilation
Right.
each day. Yeah.
That's what I mean.
Yeah. That's cool.
But the reason why they're chosen to be these sizes is based on the long cycle.
I got you.
That's what I mean. Because I mean, you could technically redistribute them to be all 30 degrees of arc.
Yeah.
Right, and just come.
You need
up
a really big one for when the universe is relatively hauling ass because we're deep in the dilation.
Scorpio.
Yeah, Scorpio is
freaking huge.
gigantic.
Actually, there's other ones that are bigger than that.
Yeah. So for anyone like wondering like about this, like there's this fascinating story. I think I've probably talked about it on the show before, but I'll just give a quick rundown of it. It's called Nightfall. And it basically is detailing the idea of what it would be like to be a civilization that's in a cosmic situation that would in some way mask the rest of the universe for most of the time so that they would have issues discovering it, right? So like if we're in this gravity mask and it's making everything weird and very difficult to understand, that's a little more subtle than Nightfall. But basically the premise of Nightfall was that there was a planet that was orbiting a 5-star system, okay? So there were 5 stars, like two like ones that are the size of the sun, one enormous giant red one, like one little bitty dwarf or whatever, and I can't remember, but they were 5 suns.
Extremely complex orbit.
Right, and they had this incredibly complex orbit, and then of course the planet itself has this incredibly complex orbit around the entire thing, and they almost never had nighttime because there were 5 stars. Like anywhere the planet turned, there was multiple stars in the sky. But it just and so like they had a hard time. Like when you're reading the story, it talks about how like they're an advanced civilization, right? They haven't gone to space or anything like that, but they don't think there's a need to because space is very small. It has 5 stars in it.
Yeah.
And that's it. They don't ever see the universe because they don't ever have nighttime. So all they know, so they think the universe is a very small bubble with 5 suns in it, you know. And it took them even though they're basically advanced, it took them forever to understand gravity because they're looking at this complicated system.
Yeah.
We have a very simple system, one big heavy thing and everything going around it. And it still took us a long time to figure out that we're all going around this big heavy thing instead of it going around us because we're spinning, right? So they eventually worked it out, and like one of the main characters in the story was the guy who figured out the law of gravity, which they were just like, oh my god, it's so simple! But when they applied it to all these complex movements of the stars, it worked out every time. They're just like, holy crap, this is amazing! But they were amazed that he figured it out because the system they had to figure it out from was so complicated. And so they were amazed that the actual calculations were so simple.
Yeah.
And they're like, how can it be this simple? Like they had these enormous papers and these long theorems trying to explain it, and this guy was like, no, it's just like inverse square law relative to the center of mass, gravity, blah blah blah. And they were just like, holy crap! It blew everybody's mind. And like also in the story, and again, keep in mind they're an advanced civilization. They have physics, all this stuff, but they had just invented candles because they don't have a light problem.
Yeah.
Right? All their buildings are very open,
Stand down.
lots of pillars and everything, but they don't have darkness in their buildings. They don't, right?
Yeah.
And they did so, and then they didn't know this, but once every 50,000 years, they had
The
nightfall.
sun set.
Right. On one part of the planet, like, they basically had all the suns set, and there was just this small red dwarf star in the sky, and then it was eclipsed by a planet they didn't know was in the system because they couldn't see it. So, like, it looks to them like it just, like, vanishes into this tunnel, and then all of a sudden, and it turns out that they're actually in the middle of a galactic cluster. So, and if anybody has been in an eclipse knows that, like, you don't see any stars until suddenly you have full eclipse and bam, they just appear, right? And so, like, every 50,000 years, their civilization totally collapsed because they suddenly saw how enormous the universe was. And it blew everybody's mind and drove them crazy, and they set everything on fire, trying to make light. So one part of the story was these archaeologists who were like trying to tell everybody, like, look, every 50,000 years there's this enormous collapse. There's like a pile of ash, and then there's all this construction and rebuilding and then everything gets more advanced, and then there's another layer of ash, and then everything builds up, and they were seeing multiple layers of this in these ruins. They kept digging down and finding another layer and another layer and another layer. And every time it's like every 50,000 years there's like a pile of ash, and then people start from zero. Right, and one of the archaeologists is trying to tell people this, and they all think he's crazy. But then he meets up with the physicists who had just figured out gravity, and they decide that they look at this ancient myth about stars, right? And they're like, there's this ancient religion about the stars that came from 50,000 years ago, and they thought it was all crazy and bullshit. But they started looking at it, and they're like, maybe there are other suns out there. And something happens where, like, we're able to see these other suns for a brief period of time, and that drives everybody mad. So they start practicing. They like put up all these curtains in one of the rooms in the physicist's house, and they try to sit in the dark, and they can't do it. And they have to open the curtain. They're like, okay, I can't take this. I can't. They've never dealt with darkness, but they had been acclimating themselves to it over a couple of weeks, because the physicist has decided, like, look, there's this pattern that we're about to have, where we're only going to have one sun in the sky. And he's like, but I don't see how that could cause darkness. But of course, he doesn't know about this other giant planet. There's a huge gas giant out there. And when it passes in front of the other sun, and then they see that it's not, he was thinking, like, maybe there's a few other stars out there. And then they see just millions, because they're in the middle of a galaxy. They're in the central cluster. And they all just go insane.
That's freaking
and
awesome.
Everyone sets everything on fire. So, like, that just, I know it's fiction, but it gives you a picture of how your sort of local situation can massively affect how you view the entire universe and your entire civilization's idea of what its place is in the universe and what's going on.
Yeah.
And so if we have something strange and subtle happening here with gravity.
This is the thing that actually sparked this idea was the fact that we haven't been noticing, like, shitloads of alien life.
Yeah. You're talking about the Fermi paradox.
The Fermi paradox. Can you explain that?
Yeah, so the Fermi paradox is basically like, and Fermi proposed this, like, basically over lunch. He was just like, where is everyone? And people were like, what are you talking about?
Just a normal lunch conversation.
Yeah, it's just a lunch conversation between astrophysicists, yeah. He was like, well, where is everyone? And they're like, what are you talking about? And he's like, well, look, you basically have all these variables. So if you say, like, the number of galaxies in the universe and the number of stars in each galaxy, right? So then you have the number of those stars that will have planets. The number of those planets that will be habitable, the number of those habitable planets that will have developed life of rudimentary form, the number of those planets that will have allowed life to evolve to a complex form, the number of those that will have evolved into intelligent beings, the number of those that will have lived long enough to build a civilization, the number of those that will have lived long enough to build a civilization that is technological and could go to space. And you still have an enormous number, even though you've been shrinking them the entire time, right? Okay, so you start out with basically the number of stars in the universe. You just, each time you do it, you're cutting it down by some, but
massive number.
You still end up like with, there should be trillions of massively advanced civilizations out there doing all kinds of shit. And so he's saying, like, the question is, where is everyone?
Yep. That's what sparked this whole thing, because they brought up the Fermi paradox, and we had talked about it before, and it's like this idea that we became unreachable.
Yeah.
Because we've also talked about the idea that, like, both the idea that there is intelligent life out there
Yeah.
and that there isn't any life out there are both equally terrifying.
Yeah, exactly. Yeah, Arthur C. Clarke. Yeah, there's only two possibilities: either we are alone or we are not. Both are equally terrifying.
Yeah, exactly. So I was just thinking about that, like, we are and we aren't.
Right.
It's the same as everything else. All the other problems.
Yeah.
Right. They're both. Is all of this gravity that's holding everything together, but there's not enough mass. There's the wave and the particle, and there's like we have all these problems where things can be one way, but then they can't be that way in another situation. And
Yeah.
it's like the idea that we are alone because we have been isolated by our situation. It would be like, a tribe. The gas station attendants on Easter Island, like
Yeah.
that they were isolated due to a specific circumstance,
Right.
and then forgot, right?
Yeah.
In their short time period, but in ours, it's like ridiculously long.
Yeah.
So we don't even need to have forgotten. We could have developed long after that, and like the rest of the universe could be teeming with all of this intelligent life, and
But it happens too fast for us to pick it up.
too fast, and
Yeah.
they can't get to us.
They may not even know we're here. If we're inside of the event horizon of a black hole, which is technically possible, right? Like, you can have a black hole where the event horizon is outside of where we are. In other words, we're in orbit around this singularity inside the event horizon. We would never be seen, but we would see everything else because all its light's falling in.
Yeah.
The light from the rest of the universe is falling in past the event horizon, and we could see it. It would be weirdly redshifted, and there would be all kinds of strange effects like accelerations across big things and redshifts
Yeah.
but nothing looking at the black hole would ever see us because
Yeah.
light can't escape the event horizon.
Right. And that goes kind of against like all of the ideas we've been talking about recently about redshift, that like maybe everything's a lot younger. Maybe it is way freaking older.
Yeah.
And these spans of time that it takes for things to develop is ridiculously longer.
Yeah.
We just so happen to get caught in a situation where we're moving through it so
Yeah.
much faster, and
Yeah.
and it's just impossible. Like, so we have these strange phenomena like the fast radio bursts, like you were saying, it's an
Yeah.
entire civilization like
Yeah. Becomes technological and disappears, and we see a
yeah, and it's like if you could slow that thing down,
Yeah.
you would actually be able to see
you
like,
get 50 years of television talk shows and soap operas, and it would be incredibly boring. And they would, and
It's
then they would
just-
blow themselves up.
I don't know, it's just another mind-blowing situation.
So there's another interesting science fiction story that I'm remembering, and I'm not going to go into this one very deeply, but the premise, one of the deep premises in the story, in the series of books, was that some alien civilization had gotten really advanced and spread out they had spread out through our part of the galaxy, right? Not the entire galaxy, but our section of it, and had been exploring about 500,000 to 800,000 years ago. And then all of a sudden they just vanished. They left everything and they just disappeared. So like in the books, people are finding their bases on asteroids still full of ships that can go into hyperspace, and right. So the idea is that eventually you figure out that this civilization, the reason they vanished is because this civilization discovered a problem that we have also discovered. This is a real thing, that the universe seems to be tuned, right? That at the instant of the Big Bang, like in the tiny like nano fractions of a second, directly directly after the Big Bang occurs, that tiny little tweaks happened that set all these fundamental laws for the rest of the universe. Okay, and the way those are all set up are so improbable with all of them together that people are questioning, like, how did this happen? This is why you have multiverse theory, to try to explain the improbability that, like, well, there's like an infinite number of universes that makes this one not improbable. Well, in this book, or in these series of books, the premise was that this alien race decided someone was tweaking it, right? That someone was present not God, but some other advanced civilization was present at the beginning of each Big Bang, and were like tweaking the universe each time. Like this was still back when they had the idea of the Big Crunch. The Big Bang would expand, and then they would come back together and poof, and then it would blow up again, right?
Yeah.
And so they suddenly realized that there's some advanced civilization out there that has been going through multiple cycles of the universe and tweaking it each time, trying to get it exactly right for their civilization. Okay, and this freaked them out. And so to get away, they all ran into a black hole. Like their entire civilization went inside of the event horizon and orbited it. They got a couple of worlds and they put them in orbit around a black hole inside of its event horizon to hide from whoever was doing this, right? And to wait it out, because like once you're in there, the rest of the universe will pass by very quickly and you can kind of like wait it out. And then you can maybe see who's freaking doing this.
Right.
Because maybe they won't know you're there because like you're hidden. But the idea was that they were doing the same thing. They would come out at the beginning of the Big Bang, they'd tweak it, and they'd go back into their black hole and wait to see did the universe turn out like they wanted. And if not, they'd wait through the entire cycle again and then come out and tweak it again, right? So that's just pointing out that like the idea that there can be black holes where you can actually live inside of it is possible. Now no one knows what a singularity would look like from inside the event horizon, right? You probably can't see it, but it would be something.
Yeah, that's another thing. It'd be like living inside a massive telescope.
Yeah.
Like it's collecting all the light and focusing it.
Right.
So that you can actually, like if you have a powerful enough instrument inside there, then you can look out and no matter how much you magnify, you're getting to see the entire universe.
Yeah.
From your local spot.
Yeah.
Right? Because you're inside this massive lens.
Yeah.
Of both time and space.
Yeah. If anybody's interested in that story, I think it's called the Hichi Chronicles. The Hichi is like a joke, basically, like because in the beginning of the story, the humans didn't know what they were, and so they just called them the Hishis. They didn't know whether they're male or female or whatever, and so the name became Hichi. And then they had this book in the story. They had this book. It was like all we know about the Hichi. It was just blank. Every page was blank because they didn't know shit.
Well, since we're plugging things, this physicist that I found and started watching a bunch of his videos. His name is Sean Carroll, and the first time I found him, he was on Joe Rogan's podcast, and this was a while back, right? He's a quantum physicist. He actually took Richard Feynman's place at Caltech.
Yeah,
he actually has his desk. He has Feynman's old desk, and he makes jokes about it being his claim to fame there. But he went on Joe Rogan's podcast, and then I saw recently that he was back. I was like, oh, cool. So I downloaded that episode, and the reason why he came back was because he was inspired by Joe Rogan's podcast, and he started his own. And it's called Mindscapes, or Mindscape.
Material escape.
Yeah, so he does basically it's a way for him to explore other things other than physics, but also physics. But with his job, he can't. He's basically expected to think about physics all the time.
Yeah,
but he's interested in all these other things too. So he gets guests that are other scientists in other fields and interviews them, and each one's like an hour long. And I've listened to about 3 or 4 of them, and it's just kind of. It's badass. So
that's cool.
I haven't listened to them all, but I think he just started it, and it's really cool. I think he's a good thinker.
Yeah.
One of the episodes was on biases, and they talked about confirmation bias and all that kind of stuff. But anyway, yeah, check it out. Mindscapes. Yeah,
Sean Carroll. Yeah, I listened to his appearances on Joe Rogan. It was cool. Massively materialist, but cool.
Yeah.
The guy is like a serious materialist. At least he sounded like that when I listened to it.
Yeah.
He's not.
He's a big believer in the many worlds theory. Like that's it. Well, I mean, I say big believer. Like that's his most prominent explanation for the problems in quantum mechanics.
Yeah.
That something can be both things until we interact with it, and then it's one.
Yeah.
And then he's like, well, it was also the other one, and that's a totally different world now.
Which makes everything possible.
Yeah. I don't, that's not my thing, man. I'm more partial to maybe we're near a black hole. And that's why things are acting very strange.
Well, it definitely seems like some kind of time dilation is happening here because we're at another break.
Man, that's crazy because the first segment seemed to take forever.
Yeah.
And the last two were just like,
Yep. Start talking about black holes and time seems to zip by. Wait, is that right?
well, what we're really
We're
trying to
far
find
away from
out.
the black hole. But if you're close, and
I don't know.
okay, if the listeners are close and we're far away, shit. Anyway,
What we're
snakes.
really looking for is black snakes.
Cannot do that. Stand down. Die.
From across the quantum sands of dilated time to the tangent cube of science, high atop the Edwards Plateau, on an ancient seabed of dilated ancient sea creatures from outside the event horizon.
black holes.
Yeah, dude. Like all those freaking ancient fossils down there. That was before we ran into the black hole.
Yeah. You know, it's like they say time flies when you're having fun, but maybe it's like time flies when you're a collapsed sun.
Yeah, that's why evolution on this planet.
But
like,
it's not your time. It's everybody else's time that flies. Like you're looking at everything, and it's like and everything's flying around. You're like, what's going on out there?
Yeah, but is there a way that this moving in and out of like near or around the event horizon or whatever of the black hole that it could actually speed up the evolutionary process because
Stand down or
of the
die.
changing of physics and
Yeah.
all the weird shit going on?
Yeah, and there's this idea of gravitic chemistry too, like the idea that once I don't know if this would affect evolution, but like there's this concept that like once gravity gets dense enough, you stop
Stand down
having chemistry
or die.
by like the weak nuclear force and you start having it by gravity. Like molecules get built by gravity rather than by these nuclear forces because the gravity is stronger, like right close to the singularity. It's so strong there that like things combine and stuff like that based on gravity rather than in chemical forces.
Yeah, dude. Totally happened.
In other words, like
It made a bunch of clams.
there could be life on black holes. Clams.
Invention of black holes. All right. All right. So I think we pretty much covered that topic.
Yeah.
I'll be kicking it around, listening to more physics podcasts, trying to figure out how it's wrong.
Yeah, and the Watcher found it's the Heechee Saga by Paul Anderson, P-O-H-L, Paul Anderson. Heechee is H-E-E-C-H-E-E. That's the story where the human race finds all these ancient ships, and then they figure out that these people have fled into the interior of a black hole. But for a long time, they don't know anything about them. The first two
Basically
books,
what they
or
figure
Frederick
out-
Pohl. I'm sorry, Frederick Pohl.
Basically, what they figure out at the end is that those people who freaked out and ran were the ones manipulating the universe. I'm just saying, I've never read it.
Yeah. No, that's not. They're terrified of whoever was
Yeah.
manipulating the universe, and they ran.
Yeah.
But the human race goes and finds them and is like, "What are you doing? What the fuck are you doing? Get the fuck out of here! Get the fuck out of here! What are you doing?" Basically, it's what they do. But the first book actually was the one that caught me. It's fascinating because it's basically like you don't find anything out about the Heechee in that book. It's all about people are going to this place because they found an asteroid that just has all of these spaceships in it, right? And the spaceships are like they're ancient. They're hundreds of thousands of years old, but they're out in space, so they're not old. I mean, in other words, they're not broken down or anything. Like
Brand new.
right? They're basically brand new.
In a cosmic sense.
But no one knows how they operate, right? But so the Earth, like all these, like the United States and a bunch of other nations, the European nations and everything, they build this coalition, and they go out there to that thing, and then they tell anybody, like, if you can get here, we'll put you in a ship. Then you can go wherever it goes. And all you have to do to make it go is you get in there and you push a button, and then it goes. You have no idea where it's going, no idea how long it's going to take, you know. And so the whole first book is about people doing that. It's about how terrifying that is, that you get in this ship and you're like, boop, and you go, and you have no idea where it's taking you. And you also have to
badass.
And you also have to take into account that, like, it's been 500,000 years since it was programmed to go wherever it's going. And so the thing that you're going to may be totally different than it was when the Hichi were going there. Right, so a lot of the ships don't ever come back because something happens, but so the book is full of mystery because people are getting in these ships and pushing buttons and then not returning, or some of the ships come back and there's no one in them.
Yeah.
You know, or they come back and the people are like spread out all over the inside of the ship, just killed, or you know, and they figure out, okay, they went near some massive gravity anomaly and just right, and they just got like
Just turn it into an amusement park. Ship flags over the solar system.
Well,
come on.
It was
folks.
like, it was kind of like a cosmic Vegas, because you had the possibility of going and find, because what they were doing was, like, if you went and you found some technology, wherever you went, you found some new technology or data, when you came back, they would purchase it from you, and sometimes people would make like billions and billions and billions of dollars coming back with some new thing.
Starbucks. Yeah.
Right. And then there were different size ships. Like, there was the 5 and the 3 and the 2 and the 1. Like, people who went into the 1s everybody thought they were crazy. You're like, you don't get into 1 and go by yourself. You're nuts. But the 1s usually went short distances, so it was thought a little safer. A 5, though, you could get in a 5 and it could be gone for years, and you run out of food and you starve to death, and the ship comes back with a bunch of desiccated mummies in it, but they've got technology in there, and then their family gets all the money from the crazy stories.
crazy.
Yeah, crazy stories.
Frederick Pohl.
Yeah, so the first like 2 or 3 books are just about people doing that. And so it's like a series of short stories of like these crazy things that they find that are completely mysterious and totally strange, and they have no idea what's going on, and they're trying not to die, and yeah, it's really cool. And then they eventually find the Hichi, but that was like the 4th book, I think. Anyway, changing, and now for something completely different. I have this other topic I've been wanting to get into, which we've touched on briefly in the podcast before, like a long time ago. But basically, this is the whole thing of spinning wheels of light in the ocean. Have we ever talked about that before?
Probably.
Okay.
Hard to say on episode 60.
So the first thing I'm going to do is I'm going to read this article by Micah Hanks. The Ocean Spinning Wheels, Mysterious Phosphorescent Light Shows in Our Oceans. Now, he's calling them phosphorescent, and that's already a giant assumption. So anyway, bioluminescence in nature is one of the most fascinating aspects of science, ranging from evolutionary modes used by insects and other creatures to attract mates, to the appearance of unusual atmospheric lights and other illuminations of possibly geophysical origin. Mysterious light phenomena occurs in a variety of different scientific disciplines. There is one particularly curious variety of natural illumination that has been reported over the years in various regions of our oceans. Although its characteristics are obviously suggestive of some unique natural phenomena, it is strange nonetheless and noteworthy among reports of unexplained nocturnal illuminations. Such an incident was discussed by N.J. Drake back in an issue of Marine Observer in 1996, where a strange formation of blue lights was observed at sea by a sailing vessel. The incident is described as follows. At 1525 UTC, whilst in the westbound lane of the traffic separation scheme, and shortly after setting a course of 270, a small amount of blue phosphorescence was noticed in the sea waves ahead. The swells were very low. Suddenly, the wind appeared to blow quite strongly, swirling around the vessel, and then for as far as the eye could see and all around the vessel, phosphorescent cartwheels of bright blue light began forming. The bands of light were roughly 30 centimeters thick, while the maximum diameter of the wheels was 15 to 18 meters. Their direction of movement seemed random, and they were spinning at high speed, some chasing each other, others spinning in opposite directions next to each other. Of the incident, P.J. Herring of the Southampton Oceanography Center noted that in the 200 or so cases of this phenomenon reported in the last 100 years, never have so many wheels been described so close together, nor have there been any association with wind change. I am very intrigued, but at a complete loss to explain how these wheels were produced.
I have an idea.
The incident was cataloged by William R. Corliss. Okay, this guy's the famous Corliss Force guy.
Yeah.
In whose work entire volumes devoted to the study of Earthlight phenomena and other forms of natural illumination. In Corliss's writings, a similar incident that occurred in 1991 bore perhaps even stranger characteristics. The incident occurred on May 6th of that year in the Straits of Hormuz, when crew members... Hey! Synchronicity. When crew members aboard the ship Zidona en route to Ruwais observed a flashing of colored lights on the windows of the ship. Initially, they mistook this for being the light from a distant lighthouse reflecting off the glass, but as the light persisted, several of them made their way to the deck where they observed strange, colorful light patterns turning in wheel-like fashion in the water around the ship. According to the record of the account, quote, they were all about 3 meters in diameter and changed both size and shape while flashing intensely. By 6 p.m. local time, the effect had completely stopped on the starboard side, and only the pulsating rings were left on the port side, and with these, the intensity of the light reduced until 6:22 when there was nothing more to observe. The unusual oceanic spinning wheels could be some variety of geophysical phenomena, although other possible solutions might include bioluminescent marine life. Granted, explaining the unusual spinning geometries of these incidents in relation to marine biology is problematic, and in some reports the illuminations appear to manifest above the water, casting further doubt on bioluminescence as a likely cause.
Destroyed my theory.
Similar incidents involving these unusual oceanic light wheels have been reported over the last several decades in the China Sea, as well as the Arabian Sea, the Java Sea, and the Gulf of Aden, among other locales. The light formations take a number of unusual shapes and have been described as spinning wheels, crescent-shaped patches, and phosphorescent boomerangs. Among similar luminescent phenomena, these oceanic lights remain unexplained and rank among the most curious and interesting varieties of unusual natural illuminations that appear in nature. Yeah, a lot of assumptions there, buddy. Okay, so I wanted to start with that article where he's basically assuming that there's some kind of natural formation, which I think is, like, you can't make that assumption. Not yet, right? But the reason I wanted to bring this up is because Ivan T. Sanderson, in one of his books, it's Invisible Residence by Ivan T. Sanderson. He has a whole section on this, and he's really studied it, and he's a good scientist. So he says, let's see, these observations have been made during every month of the year, but no less than 70% have occurred during March, April, May, and June, and 60% during the last of these 3 months. This at first looks like a natural seasonal phenomenon, but the seasons in the tropics are not defined by our calendar latitudinally, but rather longitudinally. Mostly, it is a matter of wet as opposed to dry periods. If, on the other hand, the phenomenon is life-induced or animated, it might be possible to correlate this April to June emphasis with some seasonal occurrence in tropical marine animal or plant life. Just for the record, let us examine 2 typical sightings. The first, the notice to mariners mentioned above. So, luminescence, Gulf of Siam. So this is a report. Second Officer C.J. Boys and Midshipman M. Hilbert of the British SS Telemachus, Captain J.K. Edmonds Master, reported the following. At 1906 GMT, May 30th, 1962, in latitude 7 degrees 22 minutes north, longitude 103 degrees 18 minutes east, course 166 degrees, speed 16.5 knots, dim rays of light were observed. These rays appeared to be traveling across or under the water, and came from a 210 degree direction and extended in a 120 degree to 300 degree direction. They passed the ship at a rate of 3 per second. So they're not seeing a wheel.
Yeah.
There are these rays that are going
That's crazy.
under the water, right? At 1910 GMT, these rays changed from parallel lines to curved lines, which rotated around a center, which apparently was on the horizon. So in other words, now the center of the wheel's on the horizon, and they're going, but they see it spinning, so they see the rays approaching them, and they're slightly curved as they pass.
Yeah.
Right. So it's like a wheel with a hub on the horizon is enormous, right?
Yeah. It's a 12-mile diameter.
Yeah.
Or a 12-mile radius.
They're going in a clockwise direction. The center was bearing 210 degrees. At 1913 GMT, the rays became confused, and at 1916 GMT, another group of rays, this time on the port bow, appeared. These rays were curved but rotated in a counterclockwise direction around a center which appeared to be bearing at 120 degrees. At 1921 GMT, the lines became less well-defined and slower in movement and passed the ship at a rate of 2 per second. At 1926 GMT, the rays disappeared altogether. The depth finder was turned on but showed the charted depth with no variations. So they give the wind north by west by force 1, no swell, rippled sea, barometer 29.76 inches, temperature dry 84 degrees Fahrenheit, so on and so forth. They give all this data. So Ivan says, by way of contrast, and to bring out what is probably the most important fact of all, I wish to reproduce parts of an article that appeared in the United States Naval Institute proceedings from the pen of Commander J.R. Bodler, USNR. My vessel had passed through the Strait of Hormuz, bound for India. The night was bright and clear. The third mate called me to the bridge saying that he had observed something I ought to see. At about 4 points on the port bow, toward the coast of Iran, there was a luminous band which seemed to pulsate. Its appearance suggested the aurora borealis, but much lower, in fact, on or below the horizon. Examination with binoculars showed that the luminous area was definitely below the horizon in the water and drawing nearer to the vessel. With the approach of this phenomenon, it became apparent that the pulsation seemed to start in the center of the band and flow outwards towards its extremities. So it was going... like these rings were pulsing outwards. Okay. At a distance of about a mile from the ship, it was apparent that the disturbance was roughly circularly in shape, about 1,000 to 1,500 feet in diameter. The pulsations could now be seen to be caused by a revolving motion of the entire pattern about a rather ill-defined center with streaks of light like the beams of searchlights radiating outwards from the center and revolving in a counterclockwise direction like the spokes of a gigantic wheel. So now, as he gets closer, he realizes it's not pulsing outwards, but it's got all these things and it's rotating, and that made it look like a spiral. So he thought it was spoking, but that was an optical illusion, right? They're pulsing. Okay. For several minutes, the vessel occupied the approximate center of the phenomenon. Slightly curved bands of light crossed the bow, passed rapidly down the port side from the bow to stern, and up the starboard side from aft and forward. The luminosity was sufficient to make portions of the vessel's upper works quite visible. The bands of luminance seemed to pass a given point at about a half-second intervals. So, as may well be imagined, the effect was weird and impressive in the extreme, with the vessel seeming to occupy the center of a huge pinwheel whose spokes consisted of phosphorescent luminance revolving rapidly around the vessel as a hub. The central hub of the phenomena drew gradually to starboard and passed aft, becoming more and more distant on the starboard quarter. While it was still in sight several miles astern and appearing by this time as a pulsating bank of light, so again now it's so far away they're just seeing it as a pulse. A repetition of the same manifestation appeared on the starboard bow. This was slightly smaller in area than the first and a trifle less brilliant. Its center passed slowly aft on the starboard side with the pattern of revolving luminous spokes clearly defined. It was my impression that the actual illumination was caused by the natural phosphorescence in the water, periodically stimulated by regular waves of energy. The shape of the pinwheel, the well-defined spokes, the revolutions about the center, and the speed with which each band of light traversed the water all preclude the possibility of this phenomenon being caused by schools of fish, porpoises, or similar cause. Approximately half an hour later, a third repetition of this manifestation was observed. The general characteristics, direction of rotation, etc. were the same as the others, but this one was much smaller and less brilliant. Its diameter was not over 800 to 1,000 feet, and compared to the other two was unimpressive. It was first observed much closer to the vessel than had been the case with the others. Whether this was due to its lesser brilliance or the fact that it came into being at comparatively close range could not be determined. Okay, so Ivan says, the first thing that strikes one is that these so-called wheels of light are not wheels at all, but might be better called sunbursts, like the old Japanese flag. However, some reports state that the beams, instead of broadening out as they leave the hub as do all other types of light except laser beams, appear to continue as parallel bands. Second, these underwater lights appear to have a definite point of origin. Third, this point of origin invariably seems to be moving. As in Commander Bodler's report, sometimes this center or eye appears to have moved in under a ship and, if his statement does not delude me, to have stayed there, in the case he reports, for some time and then presumably traveling with the ship. The first major point to understand is that these displays are not wheels of light, for who ever heard of a wheel without a rim? Rather, they are a series of spokes that rotate or whirl horizontally around a diffused center. Several of the reports state that the center was not brighter than the rays, but that it was mushy or almost indefinite. This is significant. Nobody seems to have noticed the outer ends of these beams as to whether they dimmed off, petered out, appeared to plunge down, or came to an abrupt stop. Let me go back and try to give a composite picture of just what these seasoned mariners have reported for, these 100 years. Mostly something like a pulsating light appears on the horizon or between the horizon and the vessel. In due course, this resolves itself into not a pulsation, but a series of beams of intense light sweeping around, apparently just under the surface of the sea. In a few cases, the witnesses report approaching a large luminous blob or mass. When they came close to, the rays shot out, when they came close to, rays shot out from it and started revolving. In several cases, more than one display has appeared at the same time or in succession. In the latter instance, they always seem to diminish in size. In this matter of size, there is apparently enormous variation. Many ships' officers have reported that, observed through binoculars from the bridges of their ships, the hubs were beyond the horizon, yet the beams swept their vessels' hulls and in most cases seem to have continued under them and far towards the opposite horizon. We're talking about enormous things here. One report made by Officer Douglas Carnegie of the display in the Gulf of Oman in 1906 states, I noticed that an intervening ship had no effect on the light beams. They started away from the lee side of that ship, just as if they had traveled right through it. So in other words, it wasn't shadowing the beams from their ship.
Right.
Like a ship that was between them and the hub, or the apparent source. Other reports appear to describe quite small displays, only a few hundred feet in total diameter, but these reports are, for one and all, frustrating because they fail to mention the exact form of the hole or how the rays ended. In one case, observed by the second officer of a Pacific and Orient liner in the Straits of Malacca, the shafts appeared to be about 300 yards long, which would indicate they terminated abruptly. There is no agreement on the width of the shafts or beams or the distance between them. When given, the width of the shaft seems to be between 20 and 30 feet, and the distance between them about 100 feet. However, the matter is further muddled by instances in which the beam and intermediate unlit areas are said to have been equal, and both about 100 feet in width. But if these beams emanate from a fairly small hub, it stands to reason that the distance the beams are from that hub would automatically alter their width if they expand like the beams of a car headlight, while the distance between them must also increase outward. The speed at which the beams are reported to travel along their circular course appears to range all the way from motionless to an estimated 200 miles per hour, but most are estimated as traveling about 60 miles per hour. This again would, of course, depend on the distance from the hub. Okay, so I'm gonna skip a bit here. He has some other... One of the things he points out is like, this is like, he's a biologist, first of all. And he points out that there is no known bioluminescent creature that can turn on and off that fast.
Yeah.
Right? So he's like, just imagine there's this enormous amount of bioluminescent creatures out there. Like, they can't flick on and off that fast to emulate beams moving that quickly through the water. They just can't do it. So that was one thing that he said. And then he was like, and then what would cause this vast emanation of them doing this like synchronous thing in the first place? Right? It seems to be a singular effect, but I'm thinking of, it almost seems like ripples from something else, some other greater force.
Yeah, what I originally thought of was the effects of turbulence in the air, like, because the first story talked about how the wind picked up, right?
Yeah.
So I was thinking of the different wheels of turbulence in the air based on like a jet's moving this way, and then there's two wheels going off to either side that are turning in opposite directions.
Right.
And the disturbance on the surface of the water is causing the phosphorus to light up.
Yeah.
Because we used to see that, we go to the beach in Florida.
Yeah.
And some of the nights, like every wave that crashed out there just lit up like bright green.
Yeah. But remember when you would go and you'd swipe your hand through the sand and you'd see them light up? They go...
Yeah. Yeah, they're slow.
Yeah.
They're turning on and off. It's
Yeah.
slow. And then we go swimming out there, and when somebody was swimming,
Yeah.
just lit up all around their body.
Yeah. And you're like, yep, every shark can see you.
Yeah. It was badass. But yeah, that obviously doesn't work with this because
I cannot do that.
that turbulence would not look like that at all.
Stand down.
Right.
So Brett posted a picture of a depiction of Commander Bodler's
Yeah.
third mate on the ship. in the
sketch
Strait
of the-
Hormuz sketch of the lights, and it shows the boat hole in the middle.
Yeah.
And there's just all these curved bands coming out like a spiral, like you would see like a shaman petroglyph or something.
Yeah.
It's like all these curved lines coming out
Yeah.
around the boat. And turbulence does not explain that.
Right.
At all.
So back to Ivan here. He says, first of all, the energy acts like a radio or radar beacon in that it sweeps the horizon. There are three possibilities. It is either inanimate, animate, or mechanical. It has always been suggested that these displays are electrical phenomena. This, in a manner of speaking, is reasonable because electrical flux belongs in the same scheme of things as radio beams, but it begs the question, what sort of electrical displays, and how come their unique form? What the suggestion is really driving at is that they are natural manifestations of electromagnetic disturbances, like lightning or northern lights. However, we do not know anything remotely like this elsewhere in any other medium. The second idea, that the source is animate, assumes that it is some manifestation of marine biology, such as the nocticula. I think that's right. Noctiluca? This is okay, that's the bioluminescent stuff you're talking about. There is more to this story. Certain kinds of deep-sea worms of the group to which our lugworm belongs come to the surface near reefs in the Indonesian and West Pacific area, but only on one night in the year. This they do as part of their breeding cycle, and at this time, the back part of their bodies is nothing but a thin-skinned, elongated sac containing eggs. These eggs are brilliantly luminous. Arriving at the surface, these egg sacs break off in the wriggling multitudes, which then sink back into the depths. These eggs are delicious to eat raw. I once sampled them off the Aru Islands in company with the locals. By the end of the orgy, all of us in the canoes were completely luminous too. A most eerie night. My initial notion was that a mass of these worms could form into a vast ball and by the creation of mass rhythmical motion somehow broadcast and then cut off their light while revolving as a whole, but I am afraid the idea did not and does not wash. These worms do not move rapidly. Besides, they are not known from the Persian Gulf. The other thing he points out, not in this part, is that they're never seen in the open ocean. These are always in seas or straits or gulfs or... He's like, there's never one in the open Pacific or the open Atlantic. They're always in these little gulfs or seas. Okay.
It's really strange.
There are luminous squids, but they can move through the water fast enough to match some of the reported speeds. But how account for the beams, all equally spaced, emanating horizontally from a diffused mass that is never brighter than part of the display? And why turning? We are left then with the third, last, and most unpleasant notion, i.e. that the source of the triggered energy is mechanical. A mechanical source could account for the regular beams of regular width, regularly spaced, and revolving at a regular speed. Hub not the brightest spot. Hubs moving on their own. Beams changing from straight to curve with increased speed, slowing down. Beams apparently on the surface, or just under it, or deep down and even sinking. Charles Fort first suggested these sources of energy were what he called constructions. He also called OSFs, or objects seen floating in the sky, now better known to us as flying saucers or UFOs, constructions. By a nimble juxtaposition of reports and cases, Ford tried to point out that the significance of all manner of fiery objects allegedly seen plunging into and rushing out of the sea. He never quite says that extraterrestrial devices, mechanisms, and craft, either robotic or manned or by intelligent entities, constantly come and go to and from this planet and use the bottom of the sea as opposed to the oceans as their landing fields and outposts. But he does hint at that the masses of oily substances reported floating near these light displays could be oil or other waste from such machines. There he stops. But let us continue this speculation as a mere intellectual exercise, of course. So he goes on there, but like those two reports and basically that whole idea, like, to me, like, it's very difficult to come up with anything that's not a construction.
Yeah,
of some
yeah,
kind.
I agree with that. It's a construction.
But like, it's also fast. Okay, so I don't know how much any of you guys have looked into UFOs, but like, the idea that UFOs come from space is kind of, it's not true. Most of them are seen coming into and out of the water. Like the vast majority of UFOs do not look like people will see them shoot off into the sky, but that doesn't mean they're going into space, right?
Yeah.
Like a plane can shoot off into the sky. It doesn't go into space. It can look like they're going into space because they can recede from you incredibly quickly and just vanish, like reach their vanishing point or whatever, or turn into a dot of light. But the vast majority of reports of these things from up close tend to be coming into or going out of water. And it's interesting because like through this book, Ivan Sanderson's book here, like Invisible Residence, that's his whole premise. He basically is looking at the entire situation of USOs, or, you know, unidentified, or what is it? Submerged, yeah, USOs, unidentified submerged objects, right? So he's going through this wheel thing because he's talking about this, and he's like looking into all these different aspects of this phenomena. And he basically is saying that like we have all these weird phenomena in the seas that can't be explained by normal biology that we understand or that we've seen, or by normal geophysical things that we understand or that we've seen, or even by natural electrical or magnetic phenomena that we understand or that we've seen.
Yeah.
Right? Now, that's not anything big. Like, one of the things we explore in this podcast is how much of this shit we don't know and haven't seen. Right?
Yeah.
But again, this is very difficult to explain.
But what has been seen doesn't fit the rest of the data. Like,
Right. That's right.
That's the problem.
Yes. And so the idea of something so enormous that that the hub can be past the horizon, and then you're having these flat beams of light pass you, you know, as it's spinning, or maybe it's like, and they change, or it'll have two of them, and then one of them's going this way and the other one's going that way. Like, it seems like mechanical, you know.
Yeah.
Like, I can't imagine. I don't know. Like, I've tried to think about this. Like, could there be some sort of geophysical, even like massively speculative geophysical thing that could cause this? I just don't know.
Yeah, I mean, you run into the same problem when you try to think of a machine that could cause it. Like,
But a machine is a machine. I guess you could just say, well, it's like some technology we don't understand. But I guess you could do the same thing. It's some natural thing we don't understand.
that's what I'm saying. Is it like it's so
But
massive.
it does act like machines that we already have, in the sense that like we have radar that does this. Right? We can't see it. It doesn't make light that we can see, but it can be detected and it works just like that.
But these are like curved beams too, so it's not.
Yeah, that is weird.
It's got to be, it's not. In other words, beams of light coming from a source because they would be straight.
They would be straight. Yeah.
To have them curved means that they're actually illuminating something in the water.
Yes.
Like whatever it is causing this strange sort of spiral illumination.
Yeah.
What could do that? I don't know.
Stand down.
Okay, so back to Ivan here. He says, having considered this wild way out theory as to the origin of these lights, we must now ask why they're formed. For this, all I can suggest is that hypothetical circular ships could have constantly running radar type scanners. That the rays they use become apparent to us only when they happen to trigger the luminosity of a mass of little one-celled creatures indigenous to our warm seas and present there in countless multitudes, or present there in countless multitudes. Maybe these constructions are all over the continental shelf. Okay, so he's suggesting that the slowness of these luminescent creatures is what causes the curvature.
Yeah.
Right? That they're reacting with some actual beam that's being sent out by a construction.
Yeah, that's what I was kind of.
And the curving appearance when they speed up is because these things are slow.
Okay.
To react to the
That's
stimuli.
what I was trying to say, is that whatever is causing it is actually illuminating something in the water,
Yeah.
as opposed to that being the direct
Right.
cause or whatever of the.
Right. Or the creatures
we're
are
seeing.
The creatures are luminescing, resulting
Right.
from it, and they're
Due to some energy.
and it's their own lag that's making it curve.
Right. Yeah. That's badass.
So he says, I tossed this at Wally Minto and asked him, as a leading investigator of underwater radiation, to rip into it. Rather than paraphrase Dr. Minto's expressions, I have sought his permission, and that of the magazine in which the article containing them was published, to reproduce it in full, because it contains so much that needs most precise interpretation. It goes as follows. As a scientist interested in the various types of radiation given off by living creatures, I wish to advance an explanation for these remarkable wheels of light observed in oceanic waters. I fully realize that advancing one possible explanation for these phenomena does not thereby eliminate other, more esoteric possibilities, because we know so little about the world in which we live. Good scientist there. But trying to fit observed fact into the framework of our present knowledge often serves to call attention to unnoticed gaps in that framework. So let us see whether scientific deduction can shed some light on this luminous mystery. First, since the observation of this phenomena seemed confined to tropical seas, or at least to warm water, this is a compelling indication that the source of the light is in some form of luminescent organism which requires such warmth for growth and activity. Because of the uniformity of illumination within the beams and at the hub, it is evident that the light sources must be dispersed through the water, in contrast to the appearance that would result if the light emanated from a single central source. In other words, since it's not brighter at the hub, then that it must be dispersed. In contrast to the appearance that it is, therefore, the evidence clearly indicates that luminescent plankton must be the immediate source of the light, as suggested by Ivan Sanderson. However, this leaves unanswered the mystery of the extraordinary pattern. Why would the plankton give off light in the shape of a rimless wheel? We know that the luminescent plankton found in tropical seas emit light when subjected to a mechanical stimulus, as shown by the luminescent wake of a boat plowing through an area suffused with these tiny organisms. But what sort of stimulating force do we know of that can induce this pattern of radiating beams? A source of stimuli that fills the requirements very nicely is underwater sound. If there are two closely adjacent sources of sound at the hub, an interference pattern will be set up. In the radial zones where the sonic waves from both sources are in phase, they will reinforce each other, stimulating the plankton to emit light. In the alternate zones where the sonic waves are out of phase and cancel each other, there will be no luminescent stimulating vibrations. Thus, we can see how a radial pattern could be generated, but let us test this hypothesis against the other observations to see whether it stands up. First, It is fully in accord with the notation that the beams pass through the ships, since their hulls would transmit the vibrations, exciting the plankton on the far side. Second, if the two central sound sources rotate slowly about each other, the radial interference pattern will also rotate. Further, because of the limited speed of sound in water, such rotation would produce a pattern of spiral spokes rather than the linear beams, again in accordance with the reports. Third, the intensity of light will be essentially uniform, both at the hub and throughout the length of the radial arms, because the intensity of light is dependent upon the concentration of plankton in the water, not on the intensity of the sound waves. As with most biological phenomena involving excitation, the sonic stimulation of plankton is an all or none effect. Below a certain threshold level, the individual organism remains quiescent. When the stimulus is above a threshold, it gives off light. So it's a 1 or a 0, basically. But increasing the intensity of the stimulation does not increase the brightness of emitted light after the threshold level is surpassed, but it does increase the distance.
Yeah.
Right. Again, this fits well into the observation that in some cases the beams had a fairly sharp termination. Naturally, the intensity of sound decreases with distance from the central hub, so at some radial distance, the intensity will fall below threshold. As a result, though the sound waves continue outward with slowly diminishing intensity, they will be unable to stimulate the plankton, resulting in a fairly sharp cutoff point. In every respect, the observations are entirely compatible with the results we should expect from sonic excitation of luminescent plankton. But what is the primary cause of this spectacle? What can we deduce about the source of the sonic waves? A wide variety of marine animals produce underwater sounds. Let us examine the clues and try to narrow down the list. Since the wheel of light is so large, the sound must be intense to disturb so large a volume of sea. Yet, if the sound were so intense, why did the observers fail to mention its presence? Logically, because its frequency fell outside the spectrum of human hearing, which extends from about 20 cycles to 15,000 cycles per second. To generate subsonic frequencies at less than 20 cycles underwater requires the expenditure of tremendous amounts of power. No living animal can generate a subsonic output capable of agitating the plankton at reported distances. So the only possibility at this end of the spectrum is some incredibly powerful machine. Because of the historical dates of the sightings, we can be sure that this hypothetical machine could not have been made by man.
I still can't really get on board with the whole... I don't see how interference pattern would make that clear of a spiral. It just doesn't make sense.
Yeah.
It doesn't make sense, especially not rotating. I don't know. I think the interference pattern would be more almost checkered, like when we looked at cymatic waves.
Yeah.
Not spiraling, because there's the spiral requires that wherever the hub is off to the side of whatever is generating the sound, because the wave front is going to be curved.
Yeah.
And the curve, one side of the curve is ending in the hub. Yeah. And then on the other side of the hub is a curve going the other direction.
Yeah.
That's not really an interference pattern.
Yeah.
I don't know. But
I thought the same thing when I was reading it. I was like, wait, I'm not picturing this.
it doesn't really make sense.
But maybe that's because I'm not able to picture it. I don't know.
Yeah, same here. I don't know.
It seems like it should go out as... Well, I don't know. Like a single source should make pulses. Like they were
Right.
initially...
What I was saying is two sources of sound would cause like a checkered effect.
Yeah.
Somewhere in the interference pattern, right? Along the interference pattern, you would see like these lines that are crossing each other, and the null areas would be between, like in the middle of the sort of checkered pattern, and it could be like diamond shaped. You know, if they're at odd angles to each other. It's just like when we were.
Well, maybe it's because we're dealing with an on-off of luminescent plankton. Is what makes it look like that. It's not that the interference pattern looks like that, it's that the on-off levels, the on levels look like that.
Well, what he's suggesting is that where the disturbance is where you basically have constructive interference, and then where there's nothing illuminated is destructive interference, so there's no disturbance there.
Yeah.
And that's going to take, like, with two waves at any angle to each other, it's going to create it's going to create like these ovals,
Yeah.
right? Or like a checkered pattern, but distorted into curves.
Yeah.
Like if you draw a series of curves going one direction, and then you draw a bunch of curves going the opposite direction across each other, you're going to see these little like oval shapes.
Yeah.
And those would be like where those lines intersect you're going to have like various constructive and destructive interference.
Yeah.
So you'll have like on-off, whatever. It just doesn't make sense that it would be that organized.
Yeah.
I can see exactly what he's saying. Like between two waves, you'd have an off period, right?
Yeah.
And then there'd be the two on periods. But it doesn't make sense that they're in a circle and extending out with no other crossing interference that's disturbing. It doesn't make sense to me. But you know, I don't know.
I wonder if one source is under the other one. So you have a source close to the surface and one beneath it.
Yeah, they would still both be sending out concentric circles.
Right. But as the circles of the one below intersected the ones above, the pattern it made on the surface might look more like that. I don't know. I'm just trying to figure out.
I don't know.
Because we're always picturing two sources like side by side. If they make concentric circles, then you get that cross pattern, right?
Yeah.
But if one's above and one's below,
Is there any way to change your perspective in a three-dimensional space that would make it look like a spiral?
yeah.
I don't know. I don't think
either.
so. But I could be wrong.
So yeah, Ivan says, personally, I am not fully satisfied with the explanation of those rays which form sinusoidal curves while revolving around their apparent hub. Despite elapsed or relapsed time in the propagation of these light beams from their center, I have failed to obtain a clear explanation of the actual method by which such precise curves can be created by switching microorganisms on and off. Also, I'm not quite satisfied with the parallel-sided laser-like beams. Just how do you confine a beam of light and then keep it confined while revolving it like a spoke of a wheel? Thus, I am afraid that I have had to resort back, though most reluctantly, to the notion that these appearances may be caused by some kind of machines. Prior to unearthing the material that I have put on record in chapters 1 through 6, I considered this quite balmy. It's quite balmy.
It's a disco ball.
But if there is a submarine civilization, or the bottoms of our seas and oceans are being used by intelligent entities with advanced machines, one can but be forced to accept the notion that their scanning or other devices might activate the Noctiluca in these remarkable manners. We just have to accept the fact that there are sound waves in both air and water, and solid matter as well, electromagnetic waves, and some other spectrum that we have not yet pinned down. The last may, as of for now and for convenience sake, be called bionic, in that its waves certainly produce effects at distance, but cannot be interfered with by the methods used to disrupt magnetic waves, such as Faraday screens and so forth.
Yeah, so he just script ripped his own idea. But
Well, that's the idea of that other guy who he asked, yeah.
oh, okay.
That's what he did. He was like, he put it into this guy.
Well, I
and was
totally
like,
agree with him.
Yeah. He's like, I'm not satisfied with this explanation. And I agree.
Yeah, it's a good idea as far as, you know, sound waves disturbing. That was originally what I was thinking of. There's something disturbing the water, and the disturbance is causing the light beams.
Yeah.
But to
In
try
the form of the Noctilucan, whatever, however you say it.
yeah,
The bacteria, the plankton.
the
luminescent
phosphorescence,
plankton. Yeah.
whatever it is.
The phosphorescent plankton that came from space.
But that's badass. I've never heard of that. That's a really cool, interesting thing.
More snake facts.
Yep. More snake facts for all you out there to contemplate.
Weird ocean wheels. Just don't stare at them too long because they'll hypnotize you and then you'll disappear. 411.
And then you will dive into the water
That's right.
to meet with the mer people.
Well, I think that's about it.
Yeah.
For episode
660.
Thank you guys very much, all of you listeners out there. I'm not going to thank anybody else, just you guys. You
Yeah.
guys have been fantastic.
We really appreciate it. Love the feedback. Keep it coming.
Loving the feedback. Loving all the love. Loving all the love. Thank you guys very much. Good night, Adamu. Get back to work.